Disclaimer: this video is for educational purposes only.
Hello and welcome. This will be the first CTF. So whenever you start a CTF, make sure you have three things. One is terminal, one is their website, and another is at notes. Okay. And this is the website and this is the CTF. Okay, and here this board game is made for absolute beginners, so let's begin. This is level 0. So they have given some SSH information, and this is the host and this is the port, and they have also mentioned that level 0, the goal of this level is for you to log into the game using SSH. So the main thing they are concentrating here is that you know the skill to use SSH. So it's not tough to learn SSH. So you need 4 things. So first of all, you need a username. Let's type it as user. Do we have a username? Yeah, Bandit 0 is the username, and here Bandit 0 is also the password. After you have those two, you also need a host and also port number. By default, SSH will have port number 22. Let me tell you the basic structure of SSH. So basic structure of SSH will be like this: SSH user host. So this is the basic structure of SSH. By host here I mean the server in which the CTF is hosted. Okay, this is the basic structure, and if you directly use this, the default port that is connecting is 22. So if there is any other specific port they have hosted, so we have to mention it something like this: -p port number. So in the previous video we have said that ports vary from 0 to 65,535. Okay, these many ports they have mentioned here. They have running the SSH server in port 2220. So we can connect using this user host -p. So host is what Bandit Labs OverTheWire.org. Okay, and the user is Bandit 0, and the password will come when you are trying to log in. So let's log in. So SSH Bandit 0 is the user, and this is the host. You can see here clearly they mentioned this is the host. So user at host, and they have a specific port in which they are running SSH, so port number 2220. So before you hit enter, let's hit enter and see what happens. Here there is a password. It is asking for a password. So let's type the password, and we are in their server. I'm not in TORHAT anymore. I'm in Bandit 0, Bandit. So let's try to understand what's going on here. Once we enter our password and hit enter, we have this shell, and this host is also changed to Bandit, and the user is Bandit 0. So what's actually happening here? So we were root before, and now we are Bandit 0. Okay, so when we try to exit from here, so we will go back again to root. So let's check that one. Yeah, we were able to successfully go back to root. Okay, so you can create n number of subshells, like you go from SSH to here and then SSH to somewhere else and something like that. And always you can always come back to your original previous shells which you have created. All the connections will be saved as a pipe. So if you stay long enough, you will experience a broken pipe. So their server may have some script running in which if you stay long enough, it will disconnect you automatically. Okay, or in your machine as well, you will have some script running. So client loop it will be doing, and then it will send a disconnect signal and it will automatically be disconnected. Let me list all the things here. You have a directory called SSH. You will not have this when you are starting. So I'll just cd into that. And then see what's there. We have two files, known host and known host old. Let's see what's inside known hosts. We have a bunch of things here, and each one is called a fingerprint. When you delete this, you will be asked to save with the fingerprint again. Let's try to delete all these things. So I've deleted and saved it, and let's try to connect to Bandit again. Let me see first. Yeah, it is empty. So known host is empty. Whenever any new connection is happening, it will ask you to save the fingerprint before you continue. Okay, so when you say S to it, it will automatically saved into known host file. Okay, so it will be, it says it is permanently added, but you can do or you can remove it. So this is the SSH information that it is saving. So let's type the password and hit enter. Something wrong. Am I not hitting it right? Bandit 0. Yeah. Okay. So when you see a lot of stuff in your terminal, you want to clear that, right? You can use clear command. Now you understand what is the basic structure of SSH, and when the port number is changed, how to connect that, and where are the fingerprints stored, and whenever it is a new file, how to store a fingerprint, and we will able to successfully connect to Bandit, right? So let's list the things here. When you want to list something in a directory which you're in, you have to use the ls command. Ls stands for list. It is an inbuilt Linux command. So ls, and there is some file here. It is listing some file. So what type of file it is, we don't know, right? So when we want to know what type of file it is, so you use file command. So use file and readme, which is the name of the file, and when you hit enter, it will show you what kind of file it is. It is an ASCII text file. It is a text file, right? So what can we do with the text file? We can print it on a terminal or open with the text editor. Okay, so to print a file, a text file on a terminal, use a cat command. Cat stands for concatenation. You can add or you can display the contents in a terminal. So here we say cat and then the file name and then hit enter. Here we have it, right? So these are the steps you take for Bandit 0 to complete to this string here. So this random string is called a flag. So when you go here, so they are saying the password for next level is in a file called readme, and whenever you find a password for the next level, use the SSH to log into the next level. Okay, so this is the password. So before we continue to the next level, we will save it. So Bandit 0, and here we say it is as a flag, and we will also write basic structure of SSH. All right. Before we do, I will write the notes later in a clear format. For now, this is what you do, and once you connect it, you need to enter the password, and so the next step is use ls, and let me write it in this format, and then next command will be cat readme. So if you do this much, the CTF is over and you got the flag. And if you want to do something else, like find other ways to do it, so I'll tell you. So here we understood that this is a text file. So what can you do with the text file? You can print it on a terminal, right? So there are a bunch of tools which you can use to print the text in a terminal. So one is cat. So people normally use cat. So you can also use head readme. You can also use tail readme. You can also use more readme. You can also use less readme. So all these are command line tools to display stuff on terminal. Okay. So when you are inside less, it will display like this, and whenever you want to get out, you have to enter Q. So that's it. And you can also display stuff in a text editor. Okay, here I'm typing readme, so it is saying enter to continue, here ER, and you can also use VI. It is also a built-in tool, built-in text editor in Linux. So here we have it. So to get out of VI, you have to type this colon Q. So Q stands for quit, and hit enter. That's it. So let's get out of this. Since we have finished it, I am a user, a root user. You can be any other user to do this. So what I'm trying to do next is, there is a SSH server running here, right? So, and we also know the username and password, and which means I can download this file here, the file which you are seeing. And so to download anything using SSH, we use some other tool called SCP, which stands for secure copy. Okay, this is the one that we will be using. So this is not a command, so I'm just writing its name here. So its command is scp. So if you type scp and hyphen help, so you will get all the commands that you will be using here. The main thing we need is this one, because there is a change in the port number of the server, so we don't need anything else. So this is the structure of the command. We mention the command name and some options, and then source, and then target. Okay, so let's type it in some format so that we will remember it. So options, and then source of the file, let me type in this way, and destination directory. So directory here means the directory. Okay, so let me create one directory in my PC here. So this is the directory which I want to let me create a subdirectory here which names 0. Okay, so here this is the place I want to download this. So let me get into the directory. So to get into that directory, we use cd command. Alright, so this will come later, so we will talk whenever this stuff comes, because there is a space in it. So how to move it? So first you need cd, it's need desktop, and ctf record, and then ctf 0. So now you're in this directory, right? Now let's clear stuff. scp, as we have said before, let me type the whole thing again. scp options, source file, destination directory. Destination directory. So we will implement the same thing here. So scp, and the option is there's a change in the port number, so we have to mention port number -p and 2220, and this is the server which we are connecting, right? User at host. So this is common, till here it is common. So this scp uses ssh in the background, so till here it is common, and here we add a colon to it. So we are mentioning in this server, in this is the file. So this tilde mark represent the home. So from here, in this home directory, there is a readme file, so we want to download it. So this we mention as a source file, and this is the root destination. So this is not the root destination, let me change it. So there's a desktop, ctf record, and ctfs, and then ctfs, and then 0. This is the directory, right? This is the source destination. A destination has to be a directory, and source has to be a file here. Okay, you can also send directories too, but here I'm sending a file. Okay, if you hit enter, it will ask for a password here. So because every time you use ssh, it will ask for a password, right? So hit enter. So password is bandit 0. Hit enter, and the file is downloaded, right? And if you open this file, you will also see the same thing. I'm opening with a text editor called Pluma. Here you have the same flag, right? So that's it for this. In this you have learned how to use SSH, the basic structure of SSH, and if there is a port change, how to change the port and connect it, and how to list the files, how to know what type of file it is, how to display the contents in different ways in a terminal and also using text editor. And if you like the CTF, you can also download it. So you've seen how we can download it using secure copy. So that's it for Bandit 0, and see you in the next one. Let's see the next one, which is Bandit 1. So this is what they have given. The password for the next level is stored in a file called dash, which is located in home directory. So let's go back to our notes and let's create a new one. Let's paste this, and let's also do this. And change it to 1. Now we have SSH, and this is the password. Let's log in. And this is the password. Alright, we're in. So they said there's a file called dash located in the home directory. Let's see. ls to list the files, and we have something here, dash, right? So this is the file name which they were telling about. So here they have given some clues like ls, cd, cat, all these you can use tools you can use, and they have given some Google search. So this is not necessary, you can actually go to this and find the answer, but the dash is also known as a hyphen. So if you don't know where it is, so hyphen in keyboard. So this is where it is. So this symbol here, right? So there is a file with that name. Okay, so let's see. So initially when we see a file, we try to use cat command, right? So cat and then file, something like this. But if you hit enter, it doesn't work. So it just keeps on waiting here. So it's not working. What's happening here? So each command will have something called an option. So all these are options. Okay, so option will tell a command to work in certain way. So this is the command and these are the options. So this is the file that we are inputting, and they have given dot dot dot. So it means that we can input multiple files in it. So that's what it means. So the main thing we need to consider is an option. So when we are trying to do something, like if we are typing cat and then dash, it is waiting for an option to be filled here. It doesn't work. So what should be done here? So in this way, the purpose of this particular CTF is to understand between relative paths and absolute paths. So relative paths and absolute path. So what is relative path and what is absolute path? So relative path is, so when we are saying if the file is still here, so we will say something like readme, like in the previous. So this is relative. Relative to what? Relative to current directory. And there is also something called a home directory. This tilde mark is there, right? So this is called tilde, which represent home directory. And if you want to say that this is in the home directory, you would obviously say that this is in the home directory, and inside this some readme file, something like that we would add. And this is we can consider this as relative to the home directory. And there is also something called absolute path. So when we want absolute path, we use pwd, which stands for present working directory. When we hit that, we will get this. So this is the full path of current directory. So when we want to use cat command, we use a full path, and in this directory there is a file called dash. Okay, so this is what we are representing with the full directory. Now it should work. Okay, now it is working. And when we want to use a relative directory, there are two ways to do it. One is this cat with the tilde mark, as we said before, and then dash. We are saying in the home directory there is a file called dash. Okay, so this should work. And one more type we can do. The dot represents current directory. So we are also saying that in this current directory there is a file called dash. So this should also work, right? So how can we say that a dot is a current directory? So if we use ls command with a, it should print out all the files and folders. So this dot actually represent the current directory, and these two dots actually represent previous directory. So we are saying here in this current directory there is a file called dash, which is here. Okay, and let's also try to list in this format. So -l stands for long listing. So when we try to list in this way, it will show in this format. Okay, here there are 10 places to fill, and some are shown some letter and some are empty, right? At present we don't want to know about all these things, so only thing you need to consider is this one, the first one. So the first one actually represents the type of file. So when there is nothing, I mean a dash is there, it represents a normal file. So it is just a normal file. And if there is some D or something like that, it represents a directory. If you try to list out everything like AL, something like this, so it should print out all this dot and double dot also. So as I said, this represent current directory. It should be a directory, right? So it should give something like D in the starting. And these are normal files. And this is the file that we are interested in, and we got the flag using that. So now we understood how the relative paths and absolute paths work. So let's move to the next one. Okay, the next one, Bandit 2. So here they have given that password for the next level is stored in a file with called spaces. In this file they have bolded it, if you can see properly. So this is the file name itself, so located in the home directory. Let's try to log in. So this is the password. Let's create a next node, number 2, and some user bandit 2, and password is this one, and SSH will be this one. So with this information, let's try to connect it. And password, it's asking for password. Yep, we got it. Let's clear the terminal. And so they said there is a password for the next file is stored in a file which has spaces in it. So let's see ls. So By first glance it seems like these are different files, right? So these seems to be like a different file, but if you type it like this by long listing, you will understand that it is a single file which has spaces in it. That's it, that's all. Okay, how do you open these kind of files? So when you try to cat this, cat copy paste, it's going to throw some errors, right? So it is thinking that spaces is a file, in is a file, this is a file, file name. So let's try to understand how the cat command works. Let's clear, let's mkdir 3 and then cd3. Now we are in, oh, it's in 2, right? Yeah, sorry. cd dot mkdir 2 and then cd2. I just went previous directory, created a directory name 2 and went into that directory. Okay, with using this colons, semicolons, it is going to divide each one into a individual command and it execute it. So this is nothing fancy. So let's try to create different text files using different methods. So let's try with nano. Okay, just enter some text, cut it, enter. Okay, done. So let's try Pluma. Pluma is a GUI text editor. It looks something like this, and I'm going to enter some text and Control S and then close it. Okay, let's try cat command this time, cat, and then usually when you type some text like this, it's going to think that this is a file and it is trying to output the contents of the file. So when we want to input some content, we put a greater than symbol that points to this file. Okay, so it is going to think that we have to enter some text here. So if you hit enter, it is going to wait there for us to enter some text. So let's type some text and then hit enter, and when you press Ctrl D, it is going to deselect from this and it's going to disconnect also. Okay, so all these contents will be sent into this file. So that's how you create contents using cat command. And there is one more command which called touch. So let's use touch and then some text. So it is going to create a file with the name dd and which has some empty contents in it, so it has nothing in it. So we have created 4 files. Let's see them all. Okay, let's create one more file. We'll use cat command for this as well, and this time we will use some new file. Okay, let's add some random contents and hit enter, Ctrl D. Okay, it's done. So now we have 5 files with one with spaces in it. Okay, so let's try to print first 3, A, B, B and C, C. Okay, we are trying to print first 3. Okay, and if you see the last one, it doesn't have any contents in it, it's 0. Okay, let's hit enter, and it is showing some contents in it, right? So it is going to first file and trying to print that, second file and printing that, third file printing that. But if you do the same thing with cat new file, it is not going to do that. It's going to think that this new is just like AA, and it's going to print the contents of this file and this file, something like that, but those files doesn't exist. So what do we do? here they have mentioned something like a single quotes here, so let's try that out. Cat and then single quotes new file, so it's going to work. Okay, and since it doesn't have any file or directory as shown here, this is as good as typing something that doesn't exist, something like this. See, it's going to print like each file don't exist at all. So we have seen the differences. Now let's get back to our main CTF, which is this one. Clear this out, ls spaces in this file. So we have seen that if you try to use single quotes, it's working, right? So let's use that single quotes. Okay, it's working. Let's try to use double quotes this time. This is also working. So there are two other ways to do this. So cat, when you use spaces, and if you try to use backslash after every name, like after spaces you print a backslash. If after in, you can type one more backslash, and this backslash, oh sorry, backslash and file name. So what this backslash does is this acts as an escape character. So what does it escape? So it escapes that this is not a different argument, this is the same file, this is a space. So it's it sends a message that the next character is not another argument, it is a continuation. So it's going to think that whatever comes next it will be the continuation. So that's what escape character do, and once you press enter, it's going to work. Oh, I have made a mistake here. It is a spaces in this file. Okay, now it's going to work. Okay, and one more way is if you type cat, and if you press tab button, which is above the caps lock, yes, and then caps lock, tab button, it is going to print this escape characters automatically for you. Okay, and then if you hit enter, it's going to work. So you can use a tab button, you can use backslash characters individually, or you can use single quotes, you can use double quotes. Okay, that's it for this flag. Let's try to copy this. Let's continue in the next one. Okay, let's do the fourth CTF, which is Bandit 3. So the password for this next level is stored in a hidden file in the in here directory. Okay, let's see what it is. So they are saying a hidden file, right? So before we start, let's do something else. /3. So what this actually does is it searches previous directory for the directory 3. Okay, it found it, and previously we have already created directory 3, so it's easy to move in this way. And let's clear this. Let's do something here. Let's create two files, touch file and some other file name. Hide it. Since we created two files, let's try to list them out. If you can see that there is only one file here listed, so let's try to do -l. Still there is only one file. Where did the other file go, right? So when there is a dot in front of a file name, it represents a hidden file. It doesn't matter whichever file it is, even it can be a directory as well, it can be a file as well, it doesn't matter. In front of the file or directory, if there is a dot, it represents a hidden file. So to display all the files, we have to type ls-a to list everything like this, or else if you want to list in a long listed format, you have to type al or la, it doesn't matter. So you will find 3 extra files here, so which has dot in it. Okay, here too. So the dot represents the same directory, the double dot represents previous directory. As I have shown before, I have searched something like this, like I went to previous directory and went inside the directory named 3. Okay, using this double dot. Okay, now this is a file which is not hidden, and this is a hidden file which will only be shown using this. Okay, so let's go back to the CTF and figure out what to do next. So here, let me copy this, add node 3 user bandit 3, pass this one, and SSH information, triple click, and then change it to 3, and triple click again, copy, right click, paste, search, double click, paste, done. Okay, so there is a in here directory, so cd into in here directory, and let's try to list things. There is nothing. Let's try to list things in this way. There is something here, like hidden file is there. Okay, so once you found a hidden file, you can simply cat it like this. You have to mention the whole name including the dot, or else it's not going to work. Okay, let's try to do something else, like cat dot and then tab. Okay, it's not going to work. So it is showing 3 different things, so you need some extra information. Let's type h and then hit tab, so it's going to fill it, right? Initially it got confused between the directories and the file itself, so you need some extra information, which is h, and then you got the rest. Autocomplete, and it gave the password. So that's it for this one. We'll meet again in the next one. All right, let's do the next one. Okay, Bandit 4. The password for the next level is stored in the only human readable file in the in here directory. Tip: if your terminal is messed up, try reset command. So your terminal will not be messed up so easily. Let's see what they are meaning to tell. Okay, so from the previous one, copy, create a node for user bandit 4, pass this one, and SSH, oopsie, and change it to 4, and we're done. Paste it, copy, right click, paste, enter, clear, and now we got this. So what they are saying is there is an in here directory. Let's list that, and cd to in here and list that as well. So we have bunch of files. So they are saying only one of them is a human readable file. In Bandit 1, we have seen how to work with the hyphenated files or a dashed file names. Okay, the file names which start with dash. So for those things we have to use absolute path only. So let's try to cat one of the file names and see what happens. So there is some gibberish thing here which is not readable at all. So this is not a human readable format. So you can apply this to all the files. So that will be so tiresome, right? So we don't want that. So what we can do is use something called a wildcard. What is a wildcard? Okay, in normal card games we use wildcards, right? So a wildcard should replace any other card. So in similar ways we have wildcards in here. So we have few types of wildcards. I'm only discussing about two of them here. So which one is asterisk and another is a question mark. Okay, there are two types of wildcards. So we will use first one, we will use both of them with full path like this, or we can use pwd and use full path as well. So we don't need that, we will use from the current directory. So how to print that? So cat and this and file name. Here we can keep a question mark which represents a single character. Okay, either 0 or 1 or 2 or something like that. So if you try to do this, it's going to print all these files one by one. So something like this will happen. It's going to print everything. So if you see here, one of them is human readable, so we want only this part. So how do we get that? We can't just capture it something like this. It might include some other files, so we don't want that. So we want something specific, like let's clear this. We will use file command just like cat command, and let's try to do the same question mark. So let's see what happens. Here we have an ASCII text on file 07. Okay, so let's copy that. Let's cat only this one, and we got the flag. So until here you understood, right? So we got the flag, and let's try to use some other wildcard also known as asterisk. You type asterisk, it should include all these files. Okay, and it should give the similar output like this. Okay, let's see. As you can see, the output is similar to this one. So what does wildcard asterisk represent? How is it different from a question mark? So a question mark represents a single character, while this asterisk represent multiple characters, which means after this in this directory, any file with any name should be acted as an input to the file command. Okay, in this way we get all these files. So here we again file 07 is there. You can use it with cat command and you will get the answer. Okay, that's it for this one. Alright, let's see the next one, Bandit 5. The password for the next level is stored in a file somewhere under the in here directory and has the following properties. So it should be a human readable one. It should have 1033 bytes, and it should not be an executable file. So the purpose of this CDF is to know the filters used to find a specific file when you already know the directory. Okay, so for this let's try to get in first. Let's see the password. Let's copy this, add node 5, paste it, change it to 5, password, this is the password. Oh, paste it, and then SSH, triple click. Alright, paste it, change it to 5, and triple click again, copy, paste, double click, paste. Oopsie. Okay, we are in Bandit 5. Let's clear this and type ls cd in here ls. There are lots of directories, so it is highly impossible to go to each and every one to find such a file. For example, let's go in maybe in here 01, and let's see, there are a lot of files here, so it's not possible to go to each directory and find all the files. So we are in here, so this is the place where we have everything, so we need some other kind of filtering system. So let's use find command. Find, so this is a complicated command, but still if you know what it is, it's going to be easy. Let's see the help menu. So its basic structure is find command, some options, and then some expressions as well, I guess. Okay, it's basically find and some options, that's all. So what kind of options are we using? We have to check here. It should be human readable and should be 1333 bytes. It is not executable. So here we have something called executable. Okay, so to make it not executable, we will use something like find in this directory, which means dot, or you can also use this one. Let's use this one. So you're saying find in this directory with what are the properties? These are the properties. So we have seen an executable option here, right? So to make it not executable, we have to keep this symbol exclamation mark, in which in programming is not executable. Executable. Okay, and to find the other options, we have a size option here. So we use size and we mention the size as 1033 bytes. Okay, here we can use a small trick to represent bytes. So we have ASCII characters, right? So ASCII characters are human readable, and each ASCII character is 8 bits, which is also a byte. Okay, so if you press characters, see here, it will include both of them. Yeah, here actually size and the number, and then here the options is given. Each one is a different one. So this C represent ASCII characters. Okay, so if you type this command this much, it includes all these three properties. So here not executable, and size is 33 bytes, and C stands for character. So each ASCII character is a human readable one, so this should work. And we got a file here. Okay, if you copy this and if you cat it, we should get the answer, the flag. So here we got something which is very long, and only this part is our flag. Okay, let's copy that. And what about all these other things, right? So all these other spaces are extra characters to make it look like it is 1033 bytes. To find that, number of bytes calculator, something like that, we have here. So here if you paste it, it should tell that it is 1033 characters or 1033 bytes. Okay, so now we have the answer here. So this is only 33 bytes. If you see, if you only replace this one. It should be 33 bytes, I guess. Okay, 32 bytes. Anyway, that's it for this one. Okay, now see the next one. The password for the next level is stored somewhere on the server and has all the following properties. So owned by this user and owned by this group and 33 bytes of size. So it's obviously human readable, so we can keep C at the end, so as we did before. So let's go back here, just copy, paste, and take this flag, paste it, change it to 6, and take this one. Paste it, enter, and then take this password, enter. Oops. Now, okay, so far good. And let's see. So they're saying they have the properties here, but they didn't say where. It's saying somewhere in the server. So the purpose of this CTF is to know the filters used to find a specific file when you don't know the directory. So previously we knew the directory, right? So now we don't know the directory. So let's see ls, nothing is there. So let's use the find command, and before using the find command, let's see our directory. So this is our directory, current directory, but previously we searched in some other directory or current directory. So we have to go back to this root directory. So let's talk a little bit about directory structure of Linux. So here we have a diagrammatic representation of directories, and forward slash stands for root directory here, and from here we have some subdirectories, and here in our command prompt we see home directory, right? So that represents this one in the middle, and in that home directory there is a subdirectory called Bandit. So this is the directory structure. So to search somewhere in the system, as we have given here, somewhere in the server, we need to go back to all the way back to the root directory. Okay, so we can go back, or else we can simply mention forward slash. Okay, currently this is not responding because the SSH connection is disconnected. So it will show a client loop, send disconnect signal, and broken pipe. Okay, so we have to reconnect this. Paste it, enter. Now we are back again. Now let's pwd. As we have said, this is the Bandit directory. We have to go back to, we don't have to go back, we just have to mention that the file start searching from root directory, so it has to search everywhere in the system. So what else did they say? These are the properties. So the first property is user Bandit 7. So in find command we let's have some find help. Let's see here, it's better to show here there is a user, and a little bit above there should be a group. Here there is a group, so user and group. So this is how you mention it. And size, we have already known how to use a size here, size with some number and with some extra parameter. We are going to use C because C stands for bytes, characters, ASCII characters, and each ASCII character is a byte. So combining all this with find, we have to write find and starting from root directory, here user is bandit 7 and group is bandit 6. Okay, and the size, as we know, it is 33 bytes and each byte is an ASCII character, so we can keep C. And let's hit enter and see what happens. Here we see lot of permission denied stuff, right? So one of which is not here. You can see, right? This is this does not have any error, so we can use it. So cat, and let's try to print this out, and we have our password. So till here the CTF is over since we found the flag. So if you want to stick around to know how to eliminate all these things and how to use redirections, pipes, all these things, you can stick around, or else this is the answer. We don't want all these errors to be shown, so we only want to print this one. So there are few things we can do to eliminate or filter out all these things. So one is redirection. So let's talk a little bit about redirection. So here we can see that the keyboard will be acted as a standard input to the process, and the process will have errors and it doesn't have errors. So which doesn't have errors will be sent out as a standard output, and which have errors will be sent to the output as a standard error. Okay, so what we are seeing here, this one is a standard output and this one is a standard error. Okay, all these are errors. Okay, so when we want to eliminate all these errors, we will use a different kind of redirection, and we want to output only the valid ones, the valid outputs which don't have errors. We will use some other kind of redirection. Okay, here we will see one more picture here. So it's just using some command, and this command has two kind of outputs. One is standard output which doesn't have any errors, and standard errors will have errors like this, permission denied or something like that. Okay, so we will output only the standard error to some file, and we will only display whichever don't have errors on the terminal. So there is a special file called /dev/null. This is a virtual device which doesn't have anything inside it. So if we type cat into it, /dev/null, it doesn't have anything. Even if you open with /dev/null, it doesn't have anything inside it. Okay, it is just a null file. So we will redirect all our errors into this file so that the output will be clean. Let's go back to our find command and redirect only the errors. So here we can see that 2 represent standard errors and 1 represent standard output. We don't have to keep 1, but we can also keep 1, or we can just we don't have to use 1. So here this is a redirection symbol, so it can act as a standard input or standard output, but depends on the direction. Means if the file is on the right side, /dev/null, it will act as a output redirection. So we want to redirect errors, so we will keep 2 and then redirection symbol, and then the file which we want to redirect it to. We will redirect it to null file which doesn't have anything, and the standard output is not redirected anywhere, so it will print on the terminal. Let's see this. Yeah, now we have a clean output. and this you can cat it out again to see the password for the next one. And we need to understand a concept called pipe. So here if you see, we have two commands and there is a pipe symbol here as a diagrammatic representation. This is command 1 here and this is a command 2, and we are using pipe to send the output of this command to this command here. So this is how it actually works behind the scenes. So this command executes and output of this command is packed and send it as a file to the next command. So remember, this is a file, this is not just output, just printing out, sending it to other. Okay, just remember this is a file. And here we are grepping out. We will talk about grep later, but as of now just remember that this focus on this one. So this is a pipe symbol. You can find it just about the enter key. Let me show that as well here. So this is the pipe symbol. You have to press shift to execute this one, shift and this key. So this is going too basic, but still it's fine. So where were we? So output of this command is packed and sent as a file to the next command. Okay, that's all you need to remember as of now. So let's use it in this command. So where is our previous command? This is our previous command. So here we will use a tool called grep. Grep stands for global regular expression print. Before that, let's see what grep is for. Okay, here we have grep and search for pattern in each file. Okay, each file and our standard input. Okay, so let's see, the one which we need is this one, because we are removing all the errors. So we will find a specific match out of this as permission denied or something else, and then we will remove all those lines and we will output only this one. So there are a bunch of ways to do this. So we'll do it in one way. We will either match this one, or if you see the output, only this one doesn't have a find here, right? So we will just eliminate the find text whenever it comes. So now we have seen both the pipes and redirections. So let's put them to the text. So now you know how the redirection works. Now, so what we need to do is, anyway the standard output comes out, right? So we also have to keep the errors as temporarily stored in the background as an input. So once we use the redirection symbol actually converts all the errors into text and then sends it to the file. But since we are also using &1, which will store temporarily in the terminal, and once it is grepped out of a pipe, it is used as a standard input to the next command, which is grep, and then we can filter out whichever we want to eliminate. So here we will grep out the pattern which we don't want to find. So since we don't want to find, we have to use -v, which stands for inverse search. Okay, so it will find all the files which have this pattern and then it will eliminate all this. So if we use this is going to work. So if we don't use this redirections, it is not going to work, because the output
of error files will always are not stored as an input to the next ones. So we have to store temporarily in a terminal like this. So we are redirecting all our outputs, including the standard errors, as temporarily as one. So this is how it works, and then we can grep out the unnecessary part and we found our output. So now we understood how to use a find command, how to use redirections and how they work, and how to use pipe commands and how to combine those two to get our output. That's it. Alright, let's do the next one. Bandit 7. The password for the next level is stored in the file data.txt next to the word millionth. Okay. First of all, let's clean this up and create a new one. Clear this up, zoom in. Paste it, enter, password, paste it, enter. Okay, so there is a file called data.txt here. If you try to see what kind of file this is Unicode text file. So it is just like an ASCII file, but even better. Okay, so let's carry it out. Cat data.txt. You see lot of content here, and they said the password is next to the word millionth. Okay, there are few ways to find this. There is a tool called grep which filters out content based on the pattern you provided. So grep -have, we have seen it in the previous video as well. So initially it doesn't need any options, so we can give optional options. We have seen this option in the previous video, this one, invert match. So we don't want certain stuff, so we removed it. So we want some stuff right now. So how do we do that? So grab pattern and the file. So we know that file is data.txt and command is grep. Let's clear this up. Grep and then pattern is millionth. So they said the word millionth and then file data.txt. That's all. Now you got the file. So the CTF is over here. You can skip if you want, or else you can stick around for a few more methods. All right. Next one. Here this is the word millionth, right? So since this is a text file, you can open in a text editor and search for the word, right? Just like Control F in your text editors. So we will use command line text editors, data.txt, and here we see Control W to find something. So where is here, right? This one, Control W, and then search for millionth, and that's all. Here you have millionth and here is the password. So Control X to exit out of here, and we will also use some other text editor called VI. So this is most popular text editor for programmers as well. So here is the file, and to search in here you have to press the / and then the word which you want to search. Here you do not see it yet, but you have to press enter to see it. Now you see it, right? Here somewhere around 337,262. So here's the file, and to get out of here you have to press :Q to quit, and that's it. Now we logged into Bandit 8, let's see. There is a file called data.txt, and let's try to cat it. 1 second. Before we do, we need to check what kind of file it is. It is ASCII text file. So cat data.txt. So there are a lot of lines here. So we need to check the only unique line. So there is a command called unique, and let's see what it does. This command takes input and prints out only the unique lines, and for that to happen, the unique lines must be adjacent as well. Okay, so it will check for adjacent line, and if it doesn't match, it is going to throw out as unique lines. Here we see that all this data is not sorted out, so first we need to sort it out as well. So for that command, for that we use sort command, and if you see the help, so write sorted concatenation all file to standard output. That's all. So it takes in the input and sorts it out and prints out in the terminal itself. Standard output is terminal. Okay, so clear that out. So in unique command, what type of options do we use, right? That's also important. So here, if you see, -u is unique, print only unique lines. So for that, also need the lines to be in sorted order. So we need to sort first and send that output as standard output to the unique command. So let's see the sorted output first. Now you see that it is sorted, and it can, the unique command can take the sorted output and it can throw out unique lines. So clear that out. Sort data pipe, it takes the output of this command and sends it to the next command as a file. Okay, so unique -u, and that should do it, because the output will be taken to the next argument here. Okay, and here we see the flag, and this is it. So the CTF is over here. We will also see one more extra thing, so you can skip if you want. So what is it that I want to show here? Okay, for the unique command to work, we need to sort the data first. So let's try to use another option here, which is C. It will count each unique lines and keeps the number to the left of it. So here, this is what happens. Here you see only one of this is not repeated. So this is the unique line. Others are repeated 10 times. So when we want to grep that thing out, so what do? The grep should accept a pattern, so it needs to be exact. What does this pattern have that doesn't exist in this one? Okay, so I'm going to select 1 and space, so this pattern is not there in others. Okay, so let's copy that and keep that in quotes so that it doesn't ignore the space as well. So if you do this, you'll get the answer here. So this is it. I want to show you the grep and multiple pipelines, multiple pipes. Okay, so output of this is taken as input to this, and output of this is taken as input to this. So that's how it works. And you can also do one more thing. You can take the above command and also ignore the ones which you don't want. So -v stands for invert match, and there is a space and 10. If you see it properly, there's a space and a 10, or you can see 10 and space, and this should also give the answer, right? Yep. Okay, that's it for this video. Alright, let's see the next one, Bandit 9. The password for the next level is stored in the file data.txt in one of the human readable strings preceded by several characters, several equals characters. Okay. Okay. We are in Bandit 9. So clear that. So they have said there is some file here, data.txt. If you see the file, it is not an ASCII text file. Okay. Is some data. So if you try to print that, you'll see all this unnecessary stuff. So okay, so there is a command called strings which will filter out strings from a binary file like this. Okay, so we see only the human readable text we can see here, right? So from these strings, if they want to extract something, so they have given a clue that it is preceded by several equals characters. So we will use a regular expression called equals equals equals. So this should print out the answer here, right? This is the regular expression we are using, and this is the answer we got. Okay, so this should be the flag. Copy and paste. Now the CTF is over right here. Flag, cannot multitask. If you want to stick around to find some other ways to do this, some simpler ways, so you can stay for some time, or else you can skip here. Clear. So since this is a binary file, we are only grepping out the equals equals equals, and strings will actually see the text file. Let me see first. Let me show you. So somewhere here there are some text which we can read, some ASCII text. Okay, so whenever it finds this text, it will print it out in a line and then skip it, and then again search for something like this. It will print it in the next line, and this one into the next line. Okay, strings acts like that, but the grep actually takes each line at a time and prints out the regular expression based on the pattern we have given. So in here, actually this can be a line. If there is any pattern that matches equals equals equals, it will print out that whole line. Okay, not just only this kind of text and then next one. So to see that in the text format, we allow it to print everything, and then from here, this is the regular expression we have given, and then data.txt. So if you do this much, it should print something, and it should also print this one, because the regular expression is this, and it is also printing something here, right? So all this includes one single line according to grep. Okay, you see here there is one more here. This exists in one line. Okay, and going to the next line, this exists in one line, something like that. So it prints the whole line regardless of binary text or ASCII text. It doesn't matter. Okay, to see that in another way, we'll see vi data.txt here. there are a lot of binary stuff here. So previously we have used forward slash to check the regular expression. Here once we have done this, it is showing the whole line, so it is in line 7. Okay, that the text the is in line 7, but if you hit enter, it is going to show the first occurrence of this pattern, and if you hit n, it should show the next occurrence of it, and then next occurrence here. Okay, and we keep on hitting n, so the password is this one. Okay, so this is how you find. So if we see previously, this is line 54. Okay, this whole line contains this pattern, so this is going to print the whole line when we use grep. So this is one other way to find stuff. Let's quit, and yeah, here you see that this is line 54 and this contains this pattern. Okay,
Here is an interesting one. The password for the next level is stored in the file data.txt, which has base 64 encoded data. So let's see what's base 64. It's easier than you think. It's nothing special. ASCII text has 8 bytes of data on each character, but base 64 has only 6 bits of data for each character. That's the only difference for base 64. So why is it used? You can go through this. So mainly to transfer different kind of data like images and all. So base 64 is used, and even for encoding some other data, base 64 is used. So people cannot read this data, but when you decipher it back to 8 bits of data, then you will be able to see it as ASCII text. So that's all you need to know about this. Let's see. Let me fill data first. Alright. So there is a data.txt file and it is in ASCII text. When we try to cat that ASCII text, we see some encoded data, right? So how can we solve this? There are a few different ways you can use it. So one is, we already have base 64 command here, so we can use this command to decipher it. So let's see what base 64 command takes input as. Here you can see base 64 encoded data file. So base 64, some options and a file. So this command is expecting a file. Okay, so -d stands for decode. So let's see base 64 and then -d, and then it's expecting a file. So let's give it a file. So base 64 -d data, and we got the password, right? So till here the CTF is over. You can skip if you want, or else you can hold on to it, hold on to the video. I'll give some other ways to do it. We have seen pipes, right? So how pipes are used. Pipe takes input from the standard input. What we can do is, we can echo and pipe it to base 64-d. So since this is expecting a file, the pipe will transfer this data into a file and then it will give the output. So this should also give the password for the next one. And we also have one more thing called Cyberchef. So here, this is a great tool if you want to use it. So here we can type base 64. So from base 64, okay, from base 64 we need to do it. So we already have base 64. Here we need to give the input like this, and it will give the output. Okay, this is much simpler. But if you see, ASCII characters are shorter than this one, right? This is a lot bigger. Why? Because each ASCII character is 8 bytes and this is only 6 bytes. So if you see, 2 bytes are transferred to the second character here, and if you see the next one, it has 4 characters and it has four more characters of ASCII characters. So this is how it is distributed. So any extra characters or extra data will be filled with random things. Okay, that's all you need to know about this. One more thing we can do is using grep command. Here we know that this file has equals, so we are using this pattern to detect equals from this file. We are transferring this as a file, and through this pipe we are sending it as a file and to the command base 64-d. This should also give the answer. Okay, these are few other ways to do it, so just try to think about how we are transferring all this data. This will help in future CTFs. Okay, let's see the next one. The password for the next level is stored in the file data.txt, where all lower cases and upper cases letters have been rotated by 13 positions. Okay, ROT 13 Wikipedia. So ROT 13 is a very famous cipher in CTFs, so might as well learn it. So this is ROT 13. So what is ROT 13 actually? ROT 13 is a cipher that shifts positions from its position to 13 positions to the next one. Okay, so what is 13 positions from here? So it is capital N, and if it reaches the border, then it again starts from A, B, C, so it goes from here to here. Okay, so this is how ROT 13 works. And if we paste our text, alright, let's log in. Asking for password. Here we will give it the password. Clear ls data.txt cat data. Let's see what's inside first. So here they have given that this is ROT 13 cipher. Okay, so just copy this and paste it here. We should get our answer below here. See, right? So the password is this one. So till here the CTF is over. There are a few other ways to do it. If you want to find out, just stay tuned to the video. Okay, so the other one which I want to tell is Cyberchef. So this is also having ROT 13, right? And here we can paste our text. Oopsie. All right. Text here, and we will get our password.
So here, as I said, if it is A, it should be N, it should be, if it is Z, it should be M, and if it is some other word, it will shift 13 characters to the right. Okay, if it is the end, it is going to repeat from A again, A, B, C and all. So this is ROT13 cipher. So we can do it in terminal as well. So to do that, we are going to use something called TR command. So let's see what it is. It is translate, squeeze or delete characters from standard input and writing it to the standard output. The TR commands takes some options, and it also takes two sets of characters from translate from this to this. So that is what translate will do, and we will talk about these later on, but as of now, set 1 and set 2 is the translate command that we will be using, and it expects some standard input, right? So standard input can be anything that comes out of standard output as well. So when we do cat data.txt, it will go to standard output, which is terminal, and when we pipe it to some other command, it will go as standard input to this command, and the TR commands expect two sets of things. So what we will do is we will write two sets which will look like A to Z and capital A to Z. So this is one set, and we will translate this set to another set, which is, if it starts from A, it should translate it to N, right? And it ends at Z. So after that, it has to repeat from A, and then it has to end at M. So this is one set of A to Z, and if it is capital A to Z, it should start from capital N and end at capital Z, and start at capital A to capital M. So this is the translate command that translate everything to ROT according to ROT13. If you see in diagrammatic form as well, it starts from A, and let's say we are taking till M, and here next letter is N, and we will go till capital Z. So here it is translated to N, and this will be Z, and then it starts from A again, and then it goes all the way to M. So this is ROT13. So this is exactly what we did. Okay, and if we hit enter, we should see our answer. Next up we have Bandit 12. The password for the next level is stored in the file data.txt, which is a hex dump of a file that has been repeatedly compressed. Okay, for this level, it may be useful to create a directory in temp directory, which you can work using mkdir. Okay, for example, this you can do, copy the file data file using cp and rename it using mv. Read the man pages. So what they are trying to say is, there is a file and it is repeatedly compressed. Okay. So let's go back, let's try to log in. Okay, here we logged in. So let's clear this out. There's a file, and if I file it, and it is saying it is ASCII text, so let's cat that file. So this is a hex dump. So this is how it is looking like, and let's see what hex dump looks like here. If there is a reading material, you can see this hex dump
it's not a hex file. Okay, it's not a hex file, so don't be confused with it. So hex dump is a hexadecimal view of the computer data. Okay, so it's not the hex file, it is a hexadecimal representation. Okay, if you execute this file, you will not get anything, you will get something like this. That's all. This is just a text file. Okay, this is not a hex file. So to make the hex file into a binary file, we need to use some tools. Yeah, so we are going to use this tool xxd. So before that, let me copy this file into my own directory. I have told you in the Bandit 0 how to copy. Let us download this file and then work on it. Instead of moving to temp directory and working on it, you can actually work on your PC as well. So let's download this. How to download this? Let's go to some directory. I'm going to clear this out. I'm going to directory and cts and create one directory, which is 12. Okay, open terminal here. You can open terminal here, or else you can copy this and exit out of here, or cd this. Okay, backslash clear. Let's download this file using scp. So we already know the scp command, scp and the port number and user@host and directory to this. So if you see that, this is the port number which Bandit server is running on. So this is the user@host, and after this a colon and then the directory. So that was in the home directory, so we are using home directory and the file name. And where do we want to copy? We want to copy in present directory. So current directory, we can copy this. If you keep dot or if you keep the whole thing, it doesn't matter, it will copy in the current directory itself. So this is the command. If you execute, it is going to ask for a password, so because the SSH is running in the background. Okay, so the password this file is this, and here we got the file. Okay, 100% transferred. Okay, let's clear this out. Let's check if the data is there. Yes, the data is there. So we are going to use this command xxd, and let's see what it does actually. So this one, yeah, this is the structure of the xxd command. Xxd and then some options and in file and out file. So here the option that we are going to use is -r, which reverses the hexadecimal to a binary file. We'll see it here. What it does is it reverses operation, convert hex dump into binary file. Okay, so xxd -d -r and then data, whatever we name it here, it doesn't matter in Linux, it is going to be a binary file as we can see here, right? This is the hex file and this is converting into a binary file. Okay, if we hit enter and if we hit ls, we have two files right now, and if we file the data, we can see that this is a gzip compressed data, and it was data2.bin and it was last modified in this date. Okay, let me cat this data.txt file. Okay, sorry. If we see here, it is telling that it is data2.bin here, right? So that's the same thing they are saying here. It was data2.bin, now it is converted into data. Okay, so it is a gzip compressed file. So here they said it is compressed repeatedly. So what we are going to do is we are going to extract repeatedly, and there are few tools to do it. One is called gzip, bzip2, and there is tar. So these are the tools that can compress or extract data. So there are other forms of these tools called for gzip we have gunzip, which stands for G unzip. So we are using G tool in the background and we are using unzip. Okay, we are not zipping this time, we are unzipping. So if gzip is there, we are compressing. If gunzip is there, we are extracting. This is another form of that command. And there is one more command called zcat. Okay, so what this zcat does is, this will show what are the contents. If it is a text file, it is going to print it as a text. So this is going to work like that. And there is something called busycat. This is for bzip, and this is also working the same way. It is going to print the output in the terminal. It's not going to extract anything. It is going to print the contents in the terminal. So what we have right now is gzip. So we will directly try to output the content data. So this is a binary file again. So we don't know what file it is. So we will again type zcat data and we will send it to file. Okay, let's see what it is. So file command will tell what type of file this is. So the next file that is coming up is bzip. So we will use again zcat data, pipe it to bzip, right? So we have to use bzcat and again file it to this. So what we got right now is again gzip. So what we do, zcat data and again zcat file. Now we got POSIX tar archive. So what we do, we have to use tar command to extract this. So there is a similar way we can output data into the terminal using tar as well. So for tar we have tar -xo, it's X capital O. So make sure you type X capital O, and next we have again file like this. So the next file is again tar POSIX archive. So again we have to type the same thing, tar -x capital O and file hyphen. So now we have bzip2 compressed data. So what we do, bzcat and then file hyphen, and now we have POSIX tar archive. So what do we do when we have POSIX tar archive? Tar -x capital and then file hyphen, and now we have gzip compressed data and gzip, right? So we have to use zcat file hyphen, and now we have ASCII text. So the file that is coming out of zcat is ASCII text. So this is a text file. So we can go up and we can just delete this part, and we can keep till here, the till zcat, and now the output will be the output which comes out of the text file. Okay, here we can see that the password is this one. So this is a one-liner to solve this CTF. There are other ways to do it, and this is the cleanest way that I can think of. And if you see ls, there are no extra files, right? There are no any extra files here. But if we use any other commands like gunzip or gzip -d, something like that, this is for decompressing. So if we use any other form like that, it's going to mess up the whole directory. So this is the cleanest way to solve this. And CTF is over right now, but I'm also going to show the other ways to do it. So if you can stay tuned, you can watch this, or else you can skip that. Thank you for watching. Okay, let's go for the next one. Here when we see file data, we got this, right, gunzip. So for gzip, we have to change the name of the file to something like gz with extension gz, or else it is going to throw some error. So I'm just going to copy this before I do anything. So let's try to extract with gunzip. Okay, so what is it? This is the actual file name. So if I do this, it is going to say unknown suffix, so it does not detect the suffix here. So we have to use this command to change the name of the file, and then if you execute gunzip, it is going to work. So if we do ls here, okay, the file actually changed to this, and then it changed back again to this. So when we do gunzip, it extracted, and the output of this file is here. So if we do file data right now, and it is going to say that it is now bzip. So for bzip, we don't need any name change, so we can use directly bunzip2, and then data, it is going to extract. So if you do ls, so this is the output we got. And if we do file data out again, so what we got here is again gzip. So for gzip, what we do, mv data dot out and data dot gz. Okay, we have to change it to gz, and then next gunzip data gz, and this is going to extract the file. And if we do ls, we are back to data again. If we do data here, it is going to say it is POSIX tar archive. So for tar, this is the command we use, -x for extracting, and we are going to extract into a file. And if we type data, it is going to extract. So we can also use -v for verbose, but we are not using it right now. So if we type ls, it is going to show this file. So this is the extracted file. And if we go and type this, it is going to show it as a POSIX tar archive again. So if you go tar xf -data5, and now it is extracted to another file again. So if we type ls, it is going to show data6. So we will copy this, and let's type file again. So now it is bzip2, so we have to use bunzip to data6, and it cannot guess, but it showed the output as this one. Okay, so we are going to copy this, and we'll see file this, and it is again POSIX tar archive tar -x, and paste this. We got an output. If we do ls, Here we got data 8, right? This is the new file that we have, and if we type file and this, it is gzip right now, and again we need to use gunzip data 8, and see, it is ignored, so we have to change the name first. So mv this and data.gz, something like this. And now if you go gunzip data.gz, there is a file called data here, so it is going to overwrite this file. Okay, so it's nothing new. Okay, we'll type yes. So now we have a file named data, file data, and now it is ASCII text. Okay, so if we cat this data, we are going to get the password. So this is another way, but this is a little messy, don't you think? Yeah, so there is a similar way, but we will use gzip instead of gunzip. Okay, gzip -d is for gzip, and bzip 2 is for bzip, bzip archives, and this is also for decompressing. And for tar, there is tar-xf, obviously, so this is the tar command that we will be using, and the file name. So this is an exercise for you, you can do this, and you can cat always the data output here and get the password. Alright, let's see the next one. Bandit 13. The password for the next file is stored in etc bandit pass bandit 14, and can be read by user bandit 14 only. So for this level you don't get the next password, but you get the private SSH key, so that can be used to log into the next level. Okay, localhost is the host name that refers to the machine you are working in. So this is obvious, right? Localhost is the same host itself. So let's log into bandit 13 SSH user @host port 2220, and here let's give the password, and we are logged in as bandit 13. So let's clear this, and let's see what's inside. We have SSH private key. So let me tell you a little bit about SSH private key. Here they have a different kind of permissions given, but this is not the usual permissions that it should be having. It should be having read permissions for the user only, and rest should be 0. Should not have any permissions. But here we are running it as bandit 13, so we have the permission to read it. Okay, so let's use this SSH private key to log into bandit 14. So here SSH, the user is bandit 14, and @localhost. Localhost is the machine itself. Since we are working in bandit server, the SSH will search in the same server for this user bandit 14, and we don't have to give any port number here. Since we are working in the same server, it is going to search for it. And next, to give this private key, you have to give -i. Let me show you what -i is. SSH, let's see the man pages of SSH. Here let's see -i. Yep, yeah, -i stands for a key, here identity file. So here this is called some private key that we are giving. So if we give that file, we don't have to give the password. So when we will go back and let's give the password. Let's give the private key. Okay, SSH bandit 14 at the rate localhost and -i and then SSH private key. If we give that, we will be able to log into bandit 14. Yes, yeah, we were able to log into bandit 14. Okay, let's get that password. Here they have given that password is here in this location, and they have given the file name also, bandit 14. So if we cat this file, we should get the password. Yeah, this is the password for the next this is the password for the current user, bandit 14. Okay, so let's save this one. So till here the CTF is over. You can stay tuned to see another way of doing this. So let's exit out of here. And let's exit out of this as well. So we know that the bandit 13 has the SSH private key. So let's download that SSH private key using SCP command. SCP. So now we are outside the server, so we need to give the port number. Okay, here we need to change something. We have to give bandit 13, and we also have to give this private key. And where are we storing this? Let us store this. Let us store this in some directory here, 13. So let's give this directory instead of dot. Let's paste this, and here, since this is there is a space here, we have to give backslash so that this will escape the space and tell that this is a single word. Okay, so now we are downloading this file. It is going to ask the password because SCP in the background works with SSH. So let's give the password for this, and we downloaded this SSH private key to this directory. So let's go to desktop. Yeah, instead of CTF12 we'll give 13, and here where is this? Oh, all right, let's move this shit to it. Yep. We can see the SSH private key, and here if we see the permissions for it, we still have these permissions. If we have these permissions, we won't be able to log in from outside. Okay, so let's try that. SSH. Now bandit 14, we have to go to bandit 14 now, and we'll give the same thing, and we also have to give SSH private key. This is not going to work because we have too much permissions here. As you can see, it is unprotected private key file. Let's exit out of here, and let's change the permissions with the chmod. Chmod will change the permissions of a file. So here we are giving 400, which stands for read for user and nothing for others. Okay, you can also do it in this way. SSH private, there's no file. Oh, sorry, this is a different file. Chmod 400 SSH key private. Okay, now this is going to work. All right, so if you go back to ls-l, it will show that it has read and then there is nothing. So now SSH command is going to work. Let's see it. You don't need any password for this. It should automatically log in.
and you can always cat this and get the password. Alright, I have found another shortcut for Bandit 12. So here's the file. So this file is the text file of hex text, and what you need to do now is to first convert it using xxt-r. This is the reverse operation of this file. So whatever file there is, this is the data.txt. Usually we give another file name as an output file, but without doing that we can directly go into this file hyphen. So this will directly print out what type of file the outcome will be. Delete that text. So this is all same from the previous video. The only thing that changes is you pipe it to zcat and then all the rest of the commands. So you pipe this xxt command to all these other commands, okay, and then you get the ASCII text file. So if you remove that ASCII text file, you get the password. Okay, this is the password you need to save for the next level. Yeah, there is a small change in Bandit 13 as well. So once you save this, so you exit out of Bandit 12. So in my previous video I have shown that it works like SSH Bandit 14 at localhost, but doesn't that work that way? So even if you type S, it's not going to work. It is saying permission denied public key. So actually what it is trying to do is it is trying the default port, which is port 22. So you need to bypass this -P2220. So here you are not using port 22, we are giving whichever the SSH server is running on, which is port 2220. So this is going to work. Bandit 14, they have said that password for the next level can be retrieved by submitting the password of the current level to the port 30,000, okay, on localhost. So I have logged into Bandit 14 using SSH. This password is located in cat etc/banditpass and Bandit 14. This is shown in the previous video as well. So we go here to Bandit 13, it is showing that the password is located at Bandit 14. So we have sent it to something that is listening in port 30,000, okay. You have to submit the password, okay. So we can do it in a few ways. So there is a server that is listening, we have to send the password. So you can send it by any means. So you can use netcat localhost. This is the most popular tool and most of the people use it. So 30,000, and you can simply text this password and this will give the next password. So this is the syntax for connecting to a server that is listening, okay. You have to use this format. So the format is netcat and then IP address and then port number. Only this part should be enough to connect a server, okay. For a server that is listening, I mean if you make a server that's listening and if you want someone else to connect to you, you have to use something like this, yeah. Netcat listen on port, okay. You can use the verbose as well, and you can set it to 30,000. with this command it will listen in the terminal for incoming connections. Okay, so you can use this password, save it for the next Bandit 14. So this is the password. Okay, this is user Bandit 14, right? So Bandit 14 has to use this password. No, it's Bandit 15 actually. So Bandit 15, okay, so this is the password for Bandit 15, and you can do it a few other ways as well. I'm just going to show some of the ways. There is another tool called ncat. So this is its syntax. Okay, ncat -help or h. This should show the syntax, like what it's going to do, and it is going to be similar to the netcat. Okay, this ncat is designed to use along with the nmap tool, nmap scanner as you know it. So let me see that. All right, so this is the usage, ncats, and some options, hostname and port. Okay, so hostname, so ncat localhost is the host, and then port number is 30,000, and you can send the password. So I've sent the password and I got the correct answer. Okay, and then you can do it with a couple of other tools as well, so I'm going to show you those as well. Previously SOCAT was available, currently SOCAT is not available, so they have removed it. So what we can do is we can use telnet also. Okay, so let's use telnet to connect to localhost 30,000. So telnet also transfers text along the servers and clients, so you can use telnet in this way, and you can paste this address and you can get this one, your Bandit 15 password. So if you want to use SOCAT, you can use like this. So you want to establish a TCP connection and on the local host on port 30,000, and then if you use hyphen, you will be able to send some data. Okay, so currently it is not available. If you press enter, it's going to be just like waiting here, just like telnet did, and you're going to paste the password and then it will give the next password. Okay, this is the SOCAT command which you need. Okay, next you can use curl as well. I don't know if curl is installed. Okay, curl is currently installed in it. So curl usually expects URL along with some options. So you can send a URL instead of HTTP. You can send some FTP or telnet or any other protocol you need. So you're just transferring data, so you can use curl for that. So use curl and telnet and : this is the protocol that you are using to transfer data, and then localhost and along with port 30,000. all right, so this will be waiting here. It is using telnet protocol, so it's waiting for me to enter the password. So I'm entering the password, so it's going to give the next password. Okay, so this is how you set multiple tools to connect to the same host and same port. Okay, right. All right, let's see Bandit 15. So the password for the next level can be retrieved by submitting the password of the current level, which is 15, to port 30,001 on localhost using SSL encryption. Okay, this is a helpful note. When you're getting this kind of error, use something else. That's what they're saying. When you see SSL encryption, we tend to use the command called OpenSSL. Okay, so usually OpenSSL will have all these commands. Okay, this is a very big application that uses SSL encryption during the data streams, and here you can see it's cookbook. Okay, you can I think you can check it for free, I guess. I'm not sure. Yeah, you can read it for free, I guess. Yeah, you can read everything for free. So what you're going to do right now is use OpenSSL tool to connect to port 30001 in localhost. Okay, so first of all, let's connect to Bandit 15. We already have a previous password. All right, let's use that. So we are connecting to OpenSSL, right? OpenSSL, and I'll just show you some basic commands of OpenSSL and its basic structure. In OpenSSL, you're checking for S client, and here is its syntax. Okay, OpenSSL and S client and some other options. So here we are going to use the first option, which is connect and then host and then port. So connect is the option, and host is the local host, and port is 30001. So S client and connect and localhost and port is 30001. All right, so it is going to read now. Okay, whatever we are trying to send, it is going to read, and we have to send its password. Okay, when you hit enter, it is going to give it is as correct, and it's going to give the next password. So that is the next password, and you can do it in a couple of other ways. So user bandit 16. I'm going to save this. Right, so next let's do it in another way. Let's use ncat. This is the same application that we have seen in the last video. So ncat, and it uses nmap in the background, and it also uses netcat. You can see ncat as a modification of netcat. Okay, let's see some ncat options. Okay, ncat. Okay, and then hyphen h for its options. So what we are going to use is this SSL option, and we are going to use another option which is going to show the end of line sequence. This is used because if you do not use this, ncat thinks that the connection is still on and it is not going to end the sequence. Okay, so you have to end this sequence by using -c. So what you're going to do is ncat hyphen capital C and hyphen SSL, and here you have to mention the local host and port 30001. Okay, so here you have to give the password for the current level, which is this. All right, it's saying wrong password, so I don't know why. Let's see the current password. Yeah, it's different one. So if you use the same command again, so now it's going to detect the end of line sequence and uses SSL encryption, and it's going to use in the local host and port number, and here we got the answer. Control C to get out of it. Alright, next see the next one. The credentials for the next level can be retrieved by submitting the password for the current level to a port on a local host. Okay, we don't know which port it is, so but it ranges from 31,000 to 32,000. Okay, find out which of these ports have a server listening on them. Okay, then find out which of these speak SSL and which don't. Okay, there is only one server that will give the next credentials. The others will simply send back whatever you have sent to it. Okay, so I have logged in using SSH Bandit 16. Okay, so yeah, I can show you again. So it is Bandit 16, and then you have to paste the password to get in. Looks like the password is a different one. So I'm just clearing. So they have said that there is a port listening. Okay, so we don't know which port it is, but it ranges from 31,000 to 32,000. So to check to scan for ports or IP addresses, there is a best tool designed for this, that's called Nmap. Along with Nmap, you have to give a couple of options and a target specification. So this target specification is the most important one. So here you can send in these ways. Okay, you can directly send the URL, I mean just the domain name. Okay, and along with /24, which is the subnet. Okay, and you can send a single IP address or a range of IP addresses. Okay, here let's see what we can do with it. So there is a basic scan. So let's go with the basic scan, Nmap, and then localhost. We are searching in a localhost, and there is a port number which we want to mention. So -p stands for which port you are specifying. So they have given a port range of 31,000 to 32,000. Okay, if you click on yes, it's going to immediately give these ports as open ports. There is a port that is listening, which is also uses SSL. Okay, so with SSL you can directly say that we open SSL. As previous Bandit we have used open SSL, we are going to use the same thing for this as well. Okay, open SSL as client as usual, and then connect, and localhost as usual, but here we have to mention the port number. Okay, it's returning nothing. And first of all, if there is an SSL, it's going to show that it is having some SSL. Okay, there is nothing here. Okay, you can see nothing. There is no peer certificate available. So you're going to do this for the next few as well. Yeah, there is a read block, but let's see if it is using SSL or not. So you have to send this current password to it. Yeah, it's going to simply print out whatever we have given. So this is not the one. Okay, then find out the SSL. Okay, there is only one server that will give the next credentials. Other will simply send back whatever you send. So this comes under others category. So this is not the one we are looking for. Okay, we don't want this. Let's keep a note of this. Okay, we only need the port numbers, we don't need everything. So I'm just saving the port numbers. Let's go with the next one, which is 31691. Okay, let's remove this, press 39691, and it's returning nothing. Okay, let's go with this. Let's go. Okay, it's also reading. Okay, you have to send this. password, and then you get some private key. Okay, so what to do with this private key? This is an RSA private key, so you have to use this private key to log into the next level. So they said they will give the password, but they did not say it as it is. They said the next credentials. So the next credentials can be a private key as well. Okay, so you have to save this private key, and let's save it in a local system. Okay, I like to use this Pluma editor. Let's save this. This goes in desktop CDF record, and then CTS, and then a new folder which is 416. Right, so this goes here as ssh.private. Okay, you can set it to any name, but I just want to set it to ssh.private. So you need to do one more thing, which is its permissions. Okay, so you need to set permissions to this. So you can see SSH private, but you see its permissions. It has read, write, and read and read. So if you use this private key, it's not going to work. You have to reduce the permissions to 400, which is only read permissions to the user. Okay, so chmod and then 400 SSH private. Okay, so that said, you can see that there is nothing here. This should work. Okay, so you can end this session and go to this next one, SSH, and then here you set it as 17. Okay, and then SSH private. So this is going to work. This I stands for identity file. Identity file will expect some private key. So that is this private key, and we are logging in to Bandit 17. Let's do this. Right. Okay, that's how you go to Bandit 17. Once you get to Bandit 17, you need to catch the flag. Okay, /etc/bandit pass and then Bandit 17. So this is the password for the next level, I mean current level, which is Bandit 17. So let's add a node. 17 user Bandit 17 has to use this password and this one, and that's it. Next one is Bandit 17. This seems to be a fairly easy one. There are two files in the home directory, password old and password new. The password for the next level is stored in password new and is the only line that has been changed between password old and password new. SSH Bandit 17 and cherry tree. The password is actually stored in here, but the password old and password new have lots of lines, but there is only one line that is unique from both of them. To find out what it is, you can use the diff command. If we do not use any options, we can directly use password.old and password.new. So what this is going to do is it's going to check each line in password.old and checks with the password.new. So whichever line that is different from both of these, those will be displayed on the terminal. When it shows the differences between these two, we have to check the second one, which will be our answer. Okay, so this is from password.old and this is from password.new. Let's clear this. I'm going to show you some other way. So that way is simple. You just take both of these files and create a new file out of this, and you will have all the lines again of both of these. And what you need to do is you sort all these things. Okay, sort, and you can check the unique line then using unique command. Okay, it's as simple as that, right? Let's try that. So for using to combine both of these files into a file, we cannot do it here because we don't have enough permissions, but we have permissions in /tmp directory. Okay, so what we are going to do is we are going to create a temporary file using mktemp command. So what it's going to do is it's going to create a temporary file. Okay, you can use this file to send the contents of these two files. Okay, so what you're going to do is cat password.old and password.new, and you're going to send all of these contents into this file. Okay, now you have contents of both of these files. Okay, so these may be ordered or may not be ordered. So what you're going to do now is sort this thing and send it to unique. So now it's going to sort all the contents and then it's going to print out the unique lines. Okay, so now you have to check the second one, which will be our password, right? Let's see the next one, Bandit 18. So the password for the next level is stored in the file readme in the home directory. Unfortunately, someone has modified the .bashrc file to log you out when you log in. Okay, they have modified this so that you will immediately log out when you try to after you log in. Okay, when you log in, after you log in you will log out. That's what they are saying. So what we have to do now is get into Bandit 18 using the previous password. Alright, we were able to log in, but then we see this bye bye message and connection has been closed. First of all, we were able to log in, so that's a good thing, and then it is logging us out. So what we need to do now, we have to log in, and after we log in we can execute some commands such as this. Okay, let's see what happens. Let's see this structure of this command first. This is as usual, so SSH and Bandit and OverTheWire.org and then port numbers, and then the next comes the command. Okay, so this is just a command, ls, the list command. So we are trying to list whatever the SSH is taking to. Okay, let's see what happens. Here we see that there is a readme as shown here, but what is that readme? That readme is the file that is in the home directory. Okay, so our command executed successfully. So they said they have modified the bashrc file. So every terminal will have some rc file, like if I am using zsh, I mean Z shell, I will have a .z shell rc file, and if I am using bash, I will also have bash rc file. So let's see what our bash rc file looks like. Okay, I will have this bash rc file. Okay, so this is how it looks like. Okay, but what they have done is they might have changed at the end of the file. Okay, instead of ending this like this, so they have changed the bash rc file to exit out of the ssh. So let's see what it looks like. Okay, so what I'm trying to do is I'm trying to print out the .bash rc file. Okay, so you know the usual cat command, right? So that cat command along with the .bash rc file. Okay, alright, till here you have seen in my PC, but here you can see some extension here like echo bye bye and exit 0. So these two are extra lines, extra 2 lines that are being executed after the bash has been run. So what we can do is we can bypass this in a couple of ways. We can simply read the readme file which is available like this. So this is the shortest thing that you can do. Here you go. But I want to show you another way. You can solve this in a couple of other ways. First of all, let me see what shells are available. Okay, I see lots of shells are available, but when SSH is trying to log in, it is taking me to this bash shell. Okay, I can use some other shell like this. Okay, I'm copying this, and instead of this I go to some other shell like this. Using -t will take you to some other TTY. That's a different concept. This command will execute and it will give a TTY. Okay, TTY is nothing but a shell. Okay, it will give a shell, and you can execute commands after. So I'm entering the password, and it will give us a shell, and from there we can execute the commands. So it is showing nothing, but all right. Alright, if you see here, there is a shell symbol here, dollar symbol, and if you type ls, you can see the readme file, and you can always get the readme file. I forgot. You cannot use, this is not a full-fledged bash shell, so this is just a normal shell. Okay, so what you're going to do now is you can have to give the complete name of the file. Okay, and then you will be able to see this one. This is not a bash shell, so you cannot expect for all the commands to work. For example, tab will not auto complete the command. Okay, and it will not fill the rest of the information, and if you use arrow keys like up or down, so those will not be executed. So this is not that kind of shell which has some extra features. Okay, so let's exit out of this shell. You can solve Bandit 18 in another way as well. Before that, I want to show you the man page of SSH, and there is something called a sudo terminal. Okay, so to check that, you have to check what is -T. So what this is going to do is disable the sudo terminal allocation. So you will not get a terminal, like it will not reach any type of shell like sh or bash or any other shell, so it will not allocate a shell to it. Okay, so you'll see what I mean. SSH bandit. So this -t at the end will disable the terminal allocation. Okay, so it's asking for a password. So it doesn't show anything right here, so it doesn't show any terminal, but it is actually logged into the Bandit 18 server. Okay, how do you know that? If you type ls, you see the readme file. So we're already in the home directory of Bandit 18. So you can also cat readme here and you'll find the answer. So that's how you solve Bandit 18. Let's look at Bandit 19 now. So to gain access to the next level, you should use the setuid binary in the home directory. Execute it without arguments to find out how to use it. Okay, so it's saying you have to execute it and then you'll find the usage. Okay, the password for this level can be found in the usual place, etc bandit pass, after you have used the setuid binary. Alright, let's log into Bandit 19 and let's take the password. Alright, let's see its permissions. Okay, so if you type ls-l, you will be able to see all its permissions. Okay, so usually this is read write execute of a user, okay, of this one, and the second one will be read write execute of group, which is this one, and then the last three will be for others. But if you see something else other than rwx, so you see here there is an s. Okay, so what this s means, this is a special permission. So what this will do is, when you try to execute as any user, okay, so any user will have the permissions of Bandit 20. So that's what they are saying. So this first three belongs to Bandit 20. So when you try to execute this file, okay, this file will be executed as Bandit 20, even though I'm Bandit 19. So this special permission will allow us to have a temporary privileges as Bandit 20. Okay, let's try to use that. As they suggested, execute it without arguments and you will find how to use it. So execute it like this, // and then Bandit 20. This is the example, like this is how you need to use it. Okay, let's type the same command and let's see what it's doing. So it gave the ID, so it executed the ID command just like this. So when I execute it without Bandit 20 here, I got Bandit 19. Okay, but here I have Bandit 19 itself, but when I see here, so this EUID, so this means effective user ID. So this is the effective user. So effective user is Bandit 20 if I run with this. So if I execute with any command with this, I will have Bandit 20 privileges. So with using that, I can directly go to /etc/bandit pass Bandit 20. So will it execute? Without this, this will not execute, but with Bandit 20 you can easily execute this because you have Bandit 20 permissions, right? So this is just a command, this is the usual command, you're just keeping this in the forward, so you will have the permissions of Bandit 20 to read this file. The next one is Bandit 20. There is a setuid binary in the home directory that does the following. It makes a connection to the local host on the port you specify as a command line argument. It then reads a line of text from the connection and compares it to the password of the previous level, which is Bandit 20. And if the password is correct, it will transmit the password to the next level, which is Bandit 21. Try connecting your own network daemon to see if this works for you. So you don't need to connect it right now, so you can directly go. I'll solve this in a couple of ways. So first of all, let's connect it using SSH Bandit 20. First I'll show you how you solve it easily, and then I'll show you some other way. So first of all, they said there is something in the home directory. So this is that. So if you see its permissions, so it has setuid permissions. When you try to execute as Bandit 20, since Bandit 20 has execute permissions here, so when you try to execute, it will execute as Bandit 21. Okay, before executing, so they are saying it makes a connection with the local host to the port you specify. Let's consider that it has already a port that I am specifying, but I don't have a port running, so I have to run a listener on a port which I want to specify, in this case 1990. So I'm gonna make a listener here, okay, with a netcat. Netcat is easy to use, so I'm gonna make a listener. So netcat options LVP. So L is for listening, and V is for verbose, and P is for port number. So this one. Okay, currently I'm listening. Now I want to connect to this port using SU connect. So I cannot do it right away here, but let's make another terminal, and not 21, it's 20. Alright, now I have two SSH connections to the same host, and one is listening in port 1990. Okay, now I'll connect using SU connect to the same port. Okay, so these both are connected. Okay, connection received. So what to do now? Connection has been made. It then reads a line of text from the connection and compares it to the password of the previous level. So which one is reading? So this one is reading. So you have to send from the listener. Okay, so not from SU connect. So you cannot paste it like this. You cannot paste in such a way. So you have to send it from here. So this is the SU connect. So this wants to connect to some port. Okay, so in the same host, probably in the same host, and so I'm creating that host here. So using netcat LVP. Now SU connect, this will connect to this, and this reads. Okay, so now I have to send password from here to here, and then it sends password back to me. Okay, Bandit 21. So that's how it works. Now till here it is complete, so the connection has been made, and now I have to send a password for it to read, and then I'll send the Bandit 20, and then it sends the Bandit 21 password. Let's do this. I'm sending the password. I hit enter, and then I receive a password here. Once it read the password, it then sent the password to the listener, and then both hosts stopped connecting each other. Alright, so I'm gonna show you another solution which you don't need two terminals to do this. You don't need two SSH connections. So for this you're gonna need knowledge of jobs, foreground processes, background processes. So I'm gonna give an overview. So usually when you run a command, it runs as a foreground process. If it is something like a listener, it's gonna take up the shell and it's going to be waiting here. When you see a netcat listener, it's going to be waiting, right? It will not allow us to send any more commands. Okay, so it's not going to allow us to send any more commands. Okay, it's going to be just waiting. So even if you type cat su connect, it's not going to work. Okay, so it's going to take up the terminal and doesn't allow us to use the terminal. So what we need to do is we need to use something called a background process. Okay, so background process works like this: LVP 1990, and then if you put a ampersand at the end, it's gonna run in the background. So now if you try to run any command, you can run any command here. Okay, so where is this process? If you want this process, you need to check the jobs command, JOBS. Jobs is where the background processes are listed. Okay, so this is listed here as a background process, and when you want to bring the background process to the foreground, so you have to use FG command. And if you want to send this to background, first you have to use Ctrl+Z, and then you have to type BG. This will take the process netcat LVP to the background. I'm going to show you. And if you type jobs again, the process is listed here, right? It is running in the background, and we got our shell back, and you can type few more commands. So this is the overview, like how this is going to work. But in our case, we are going to need two terminals, right? So in this case, what I'm going to do, I'm going to run a netcat command and send it to the background process. Okay, netcat listener. Okay, I'm going to type L, and I'm going to type another background process because I need to shift from one command to other, right? So I'm going to need su connect, and I'm going to send it to background process as well. I'm going to bring the netcat listener to the foreground, and then I'm going to send the password, and then I'm going to send this back to again background process. So then I'm going to bring the su background process to foreground and then see what's going on. So it will close the connection automatically because the password has been received by su connect, and then if you try to open this foreground process of netcat, you will see the password. Okay, so this is how it's going to be. Let's see that in action. Okay, first I open a netcat listener, and then I'll send it to background. Okay, Ctrl+Z and then BG. To check the process if it is running in the background, I'll use the jobs command. So I see that there is a process running in the background. Okay, so now I'm gonna use su connect to connect to this process. Okay, you see that there is a connection received on the local host 54912. So this message, this is from this background process. Okay, so this has received the connection. All right, now what I'm gonna do, I'm gonna stop the connection. I'm not disconnecting the connection. I just want to send it to the background. Okay, so when I sent it to the background, you see that there is one message saying that number 2 is sent to the background. Okay, the ampersand tells that it is running in the background. Okay, so if you see the jobs command now, so there are two processes running. Okay, this is showing stopped. That means this is temporarily suspended, but this is still running in the background. Okay, if you type fg1, you will be able to run this command, which is number 1. As you can see here, this is number 1. So I type foreground 1. Okay, so now I want to paste this password and hit enter. I see password matches and I see the next password, and this has closed automatically. Okay, and the final netcat process also closed automatically because the connection has been closed. This is how you shift the processes and solve this level. The normal process by using two terminals is easy one, but it is good to have this knowledge where you have to use foreground and background processes. Alright, let's see the next one. Bandit 21. A program is running automatically at regular intervals from cron, the time-based job scheduler. Look in etc cron d. Okay, we'll see that later. Okay, for configuration and see what command is being executed. Right. Okay, this is fairly easy. I'll show you a few things. Okay, first of all, let's log into it. So 21. All right, there's nothing here. They said we have to go to /etc/cron-d. Okay, cd and that, and if we ls it will show all these things. The one we are interested in is this one, because that's what will get us into Bandit 22. Okay, first of all, what is this directory? This is a cron daemon directory. What does it mean, the cron daemon? Cron is a job scheduler. It schedules the jobs. Job in the sense is a process or a script or whatever it is. What it mainly does, it runs the scripts in a periodic time that we mention. Okay, where can we find all these scripts, all these executables? In this directory. Okay, and you can also find something like this, cron tab -e. Okay, you don't have permissions, but in my PC I do have permissions. Okay, so I'm just gonna open cron tab -e. Okay, if you type this command, it will execute this cron tab. Okay, so it is just a text file, which editor you want to run this with. Okay, I'm gonna choose nano. So here it is. Okay, currently I don't have any jobs running. Okay, this is the format that you should be interested in, because this runs at time you mention. Okay, hours and minutes. So hours will be from 0 to 23 and this will be from 0 to 59. Okay, and this one, date of the month, 0 to whichever month it is. It is 1 to whichever date it is. It is a date of the month, okay, it is month number and then day of the week, okay, and then the command. If you see here, it shows an example, and this example shows that it runs a backup of all the user accounts at 5 a.m. every week. So they did not mention specific week, but this one represents Monday, okay, 0 represents Sunday, and 0 1 2 3 4 5 6, okay, and then this is 5 hours, as you can see here, 5 hours 0 minutes, and it doesn't matter day of the month and month number, and this day of the week is Monday, okay. tar is the command we have seen in the previous videos, okay. tar, it creates a file called home.tcz. It stores in backups directory of var directory, okay, and it takes all the files from home directory, okay. This is what it means. And this jet represent gzip files, okay, gzip. We have seen this before also, gzip, gcat, all these things, okay. This creates a file which called home.tcz, and then it takes all the files from this and then stores it in backup directory. That's what this cron example does. And you can create a simple scripts like this, but here we don't have permissions. Possibly when you save all these files in a cron/d directory, it will automatically run all your scripts, okay. Let's see what kind of jobs it is running, okay. Cat, cron job, bandit 22. As we can see in this file, it shows at reboot bandit 22 has to execute this script, okay. So this script will be run with the permissions just as bandit 22, okay. And then it doesn't matter which day of the month or week or whatever, time, hours, okay, it doesn't matter which time it is, and then bandit 22 will run this script. So let's see what is inside this script, okay. So to see what is inside the script, you just copy it like so, and then cat the file. As you can see here, this is chmod 644, and in some temp directory there is a file called this, okay. We don't know what it is, and this cat command will send the bandit 22 password to this file, okay. That is what the script is telling. So this script will execute periodically. Since the password is sending directly to this file, if you try to open this file, okay, using cat, you will get the password. If you are seeing cron jobs for the first time, it is nothing but just a background process that runs periodically, okay. So nothing to be afraid of. You'll find the scripts in this place, or you can write the scripts directly in the cron tab -e, okay. In this you can directly write the scripts. You have to write it in this format, okay, and you can specify at reboot if you want, but this is optional, okay. And then this will run continuously, right. I'll just explain this script a little bit more, okay. This is saying at reboot, and this is saying at whichever time, it doesn't matter, okay. So this is the same line here, both are same lines. So those two lines are individual, so they doesn't belong each other. This works at reboot, okay. This is only working at reboot, and this works every minute, okay. This works all the time. So that's what it means. See ya. Let's look at bandit 22. So a program is running automatically at regular intervals from cron. the time-based job scheduler. Look at etc cron d for the configuration and see what command is being executed. Okay, looking at shell scripts written by other people is very useful skill. The script for this level is intentionally made easy to read. If you're having problems with understanding what it is, try executing it and debug information it prints. Okay, this comes under the same concept, which is a job scheduler. Okay, we'll see after we log in. This is the same. Okay, so nothing has been changed. Now we have to look at cron job bandit 23. So it's the same. You have to cat the file to see what it is. This is in the same format as previous level. Okay, add reboot, run as bandit 23, run this shell script, and errors or output, send it to dev null. Okay, do not print anything on the screen. And then this one, run at any time as bandit 23 and run this shell script, and whatever errors or output is just send it to dev null. Okay, and let's see what is inside this script. So this script uses the bash interpreter. Okay, if you don't know what is an interpreter, you should look it up. So if you do not place this, you have to specify either bash or any other shell. But if you do specify this, you can directly run the shell script such as this. Okay, you can simply run it. Let's see what the shell script is saying. So it is having a variable which is taking who am I. So if I'm typing who am I, so it will give bandit 22 because that is what I am right now. Okay, but here if you're executing as bandit 23, it will execute as bandit 23 here. Bandit 23 will be here, and bandit 23 will be stored in my name as well. In the next line, you're having another variable which is storing this part. Okay, so this is kind of a variable as well, but this is having an echo command. Okay, echo I am user and my name, which is bandit 23 here. Okay, bandit 23, which is this, and then it is undergoing through a hashing process which is called MD5, and then the output of this hash has been cut in certain format. Okay, let's see what it is. Let's see the echo command. Okay, I am user bandit 23, so that's what it should be. Okay, so this is what it is printing, and let it go through MD5 sum. Okay, and then MD5 sum, and it is giving this part. And what this part is doing, so it is taking the delimiter. Okay, cut simply strips away the unnecessary data, okay, which we specify here, and then whichever we specify as a field, so that will be printed and rest will be cut. Okay, and we are using a delimiter here. Okay, -d stands for a delimiter. Delimiter simply divides a string into arrays. Okay, that's what it is, and we are using space character as a delimiter. Here if you see space here, so that will be the delimiter here. So that will divide this part and the rest of the part. Okay, and here the field we have selected 1. Okay, so field 1 stands for this. Let's see it in action. Okay, cut. All right, let's copy paste the same thing. Okay, let's see. Copy, paste, and then enter. So this just stripped off this part. Okay, and then we'll copy this. And what is the next part of this? Okay, this is done. The next line is saying echo copying password file /etc/bandit pass, and then my name, which is bandit 23. Okay, and then to /temp/my target. So, okay, this my target variable is this one. Okay, so whatever comes out of this will be my target, and my target is here, and /temp/my target. Okay, so /temp/this. Okay, so that's what it is saying. So if you see cat /tmp/ and then this file, and this should be a file, and you should be able to read it, right? And here is your flag. This level and previous level do not seem to have alternate paths, so we're just going through logic. Okay, so first we find this, and then we read this script, and according to this script we executed the commands and found the solution. Okay, so this doesn't seem to have an alternate solution. Alright, let's see the next one, Bandit 23. A program is running automatically at regular intervals from cron, the time-based job scheduler. Look in xcron-d, okay, for the configuration and see what commands are being executed. Okay, this level requires for you to create your own shell script. This is a very big step, and you should be proud of yourself to beat this level. Okay, keep in mind that the shell script is removed once it is executed, so you may want to keep a copy around. Okay, you don't need to keep a copy around. Alright, let's see what's going on. Right, SSH bandit 23, and then the password for this is this, right? And then you need to go to this directory, and then C cat cron bandit 24. All right, and then cat the same thing as usual as we did before. So we need to see what this script is telling us. So this is the script. Okay, and what it says is, so there is a bin bash, the interpreter, and then my name is who am I, which is bandit 23 for us, but it should be bandit 24 if we want to get the password. So what it's actually telling is executing and deleting all the scripts in this directory. Okay, so we need to keep this one in mind. Okay, let's copy that and keep it here. Okay, and the next step is for I in anything, which is a file. Okay, do this one. Okay, what it is, so $i not equal to dot and okay, $i not equal to double dot. So what it is saying is, if it is the current directory or the previous directory, as you can see here, ls-a, you can see these two, right? These two are directories. So what they are trying to do is they are excluding the directories of current one and previous one, and whatever is remaining, so you need to delete that. Okay, rm-f, and this represent every file. Okay, So I represent the file name, okay, and then whatever is in the current file of current directory, everything has to be deleted. Let's see what this says. Okay, and then cat, no, this has to be like this, cron 24. Let's see. So it is saying it is root. Okay, the user active, the effective user is root. Is that what it's saying? Yep. So the user is root, which is created this, and so what this command is telling us is if the file which it is taking here, so the current file, for example, this is the file of a user, and since the file of a user is there, so the user name will become the owner. Okay, here the username is root, so that will become the owner here. So if that owner becomes bandit23, then timeout and execute this. Okay, wait for this much time and then execute this, right? And then after that delete that file. Okay, so let's repeat. So initially it captures bandit24. Okay, captures bandit24, and then it goes to this directory and then executing and deleting all the files. Okay, if for I in any file, okay, it's going to check if it is a current directory or previous directory, and ignores those two, and whichever is left, okay, whatever is left, it's going to capture the owner of the file, and then if it checks the owner with bandit23, okay, if it is bandit23, then it's going to wait and execute, or else it simply ignores and deletes the file. Okay, if it is the owner is bandit23, only then it will execute. If bandit23 is not the owner, it's going to skip this part and simply removes the file. Okay, so what we need to do, we need to send a file to this directory. Okay, so that this cron job will execute this script, so that our file as bandit23 will execute, and then we will use that feature here to get our password. Okay, I repeat, so we need to send a file to this directory so that all the files with bandit23 as a user will execute, and then we will use this feature to get our password for the next. So how are we going to do that? There are a couple of ways you can do that. The first method and the simplest method which I'm going to do is use mktemp. Okay, what this command will do, it will create a file in the temp directory. Okay, this is a file. Okay, and then what we're going to do, we are going to send some text into it. Okay, so let's write something to this. Okay, and then what are we going to write? We are going to write shebang /bin/bash. I'm just writing into this file using cat command. You can also do that, or you can use any text editor like VI or Nano. I'm gonna show that as well in 5 minutes. Okay, and what I'm trying to do is I'm going to first mention the interpreter, which interpreter am I going to use. Okay, if I do not use this, so I need to execute it as as bash and then file.sh. Okay, so this is the script I have to execute using any shell. Okay, so if I don't want to mention this, I have to keep an interpreter like this. So if I have an interpreter like this, if I have an interpreter like this in the first line of the script, so I just have to keep /, and then the file will execute, or else you have to give a full path if it is not in the current directory. Okay, hope you get it. Next, what are we going to do after we mention the interpreter? We are going to copy. What are we going to copy? We are going to copy a file from etc bandit underscore pass and bandit 24 password, okay, to the same file. Okay, we are going to mention this file itself. So this is the easiest way if you understand it. So what are we going to do? We have wrote this script. Okay, so this script will have the content this, but after executing this script, the contents of bandit 24 will be sent to back to this file itself. Okay, all right, now press Ctrl D, okay, to get out of it, and then if you see the contents of the same file, this will be the script. Okay, now in order for bandit 24 to execute it, so we need to give bandit 24 some permissions to execute it. And then this file, you see no one else has the permissions, so when it goes to this directory, bandit 24 is the owner of this directory, so we have to give permissions to bandit 24 in order for this to execute. So how are we going to do that? Since this is a lab environment, we can give every permission that is possible. Okay, chmod 777 and then this file name. Right, now the permissions have been given. Okay, it has the execute permission, so now bandit 24 can execute it. So where do I need to send this file? I need to send this file to this directory. So instead of my name, I have to keep bandit 24 here. So what I'm going to do, I'm going to copy this file to /var/spool and then bandit 24 and then foo. All right, so I'm sending this file to this directory and I'm going to wait. So this was successful. This has all the permissions, so everything looks good. Okay, I just need to wait for a couple of minutes. Sorry, my syntax was bad here, so I just need to paste this like this. Okay, so it should not be like a redirection, so it should be like this. All right, so now I have done it. Ctrl D. So now I'm out. Now let me send this file to this directory. Okay, and we will wait. All right, just a moment. Right, now we got the password. Right, flag and then password. Right, we got this password. Now let's do it in a couple of other ways. Okay, now what I want to do next is, let's clear this up and then Control L to clear. Okay, and then mktemp -d will create a directory. Okay, this is a directory. Okay, this is not a file now, this is a directory. You can actually go into the directory. So what you need to do is Now just think about it. This directory has the owner Bandit23, so no other can send files into this. So first we need to do is we need to give full permissions to this directory, and then we need to create a file. Let's create a file. Now this time let me use nano editor, okay, nano or vi or whatever. Let me use nano for simplicity, and then let me type script.sh. Now we have the script. Now let me do in a different way. Shebang bin bash copy. This time let me copy etc bandit pass, okay, then bandit24, and then let me do it in a different way. This time I don't want to use copy, I will use cat, okay, since I've already used copy. Let me use cat, and when I'm printing out the password, I will just redirect into this temp directory, okay. This is not easy to copy right now. Let me exit by saving this. Let me copy this, and then let me go back to the script. This time I will paste it here. Since this is a directory, I need to mention a file password, okay. So this is just a file, okay, just a normal file, text file. So this is not yet created, but when the script execute, this will get created, okay. Now that's all. Now you can also use head or tail or new line or whatever you can use, okay. Instead of cat you can use all that, okay. Now let me close the script and then give all permissions as usual to the script. And if you see, we have only one file right now which has all permissions, but this is going to change and you're going to get an additional file, okay, when the script executes. So now let's send this file to copy script and then /var/spool/bandit24/foo. okay, now I've sent this file. We have set everything, okay. Now let me ls-l for some time, and let's see if that script executes and then password shows up. Everything looks cool. I don't see any errors. Yeah, as you can see, we see password file. So if you cat the password, you get the password, okay. You can also modify a script a little bit, okay, since it is nano. When you're using a copy command, okay, you need to usually mention a directory, okay. Here if I'm using copy command and if I'm not using this password, this is also going to work, and the name of the file will be bandit24, okay. But if you are mentioning, for example, let's change it to like pass1, so this is not yet created, okay. But when the script executes, the contents of this file will be copied and a new file will be created in the name of pass1, okay. These are the various ways which you can solve this, but the main thing to know is that to use shebang. Okay, if you do not use it, that will cause a problem. And the main problem you might encounter is giving permissions. Okay, so if you are creating the directory, you need to give the directory also the permissions. Okay, so that the other person can send a file here. Okay, right. And if you are using just a file just like that, okay, this is just a file, and you need to give all permissions to this file so that other person will execute and other person can also send file here. Okay, you need to take care of those things and you'll be good. Okay, this is an interesting one. This is the last part of a bash scripting. Okay, let's see what it is. A daemon is listening on port 30002 and will give the password for the Bandit 25. If given the password for Bandit 24 and a secret numeric 4-digit pin code, okay, we don't know what that pin code is, but we know that it is 4-digit pin code. Okay, so there is no way to retrieve the pin code except by going through all of the 10,000 combinations, called brute forcing. You do not need to create new connections each time. So you do not need to new connection. You just set up a connection and set the inputs. So what kind of inputs is it expecting? So it is expecting Bandit 24 password and a 4-digit pin code. So it should look something like this. Okay, I'll just paste it and then space and then 4-digit pin code, something like this. Let's log into it. SSH Bandit 24, then paste it. So they said it accepts a connection. So let's make some connection. Okay, let's make some connection without anything. Okay, localhost 30,002. Okay, so I am pin code checker for Bandit 25. Okay, please enter the password for Bandit 20 and the secret ping in a single line separated by a space. As I said here, it should be something like this. Okay, so if we enter these values, it's gonna say it's wrong. Okay, so if we enter something else, okay, something like this, it's gonna say wrong. So we don't know what the right pin code is, but we know that Bandit 24 password is this. So this needs to be brute forced. So for that we need shell scripting. So let's try to understand it. Pay attention. Now I'm going to create a directory using mktemp. Okay, -d will give directory. Okay, so I'll just go into it. Easy. And then I'm going to create a shell script, nano, and then some script. Okay, here you can use bin bash, okay, like this, or you don't need to use it. Okay, people often use it as a precaution. Okay, but you don't need to use it. I have already told the difference between this shebang line and not using the shebang line. So if you use the shebang line, you have to execute the script like this. It's not mandatory, but you can execute script like this. Okay, if you do not use shebang, you have to use bash and then script.sh. Okay, in previously I have used shebang, so in this case I don't want to use it. Okay, I can ignore this. So what I need to do, I need to give password and this 4-digit pin number, and I need a lot of them. I mean 10,000 of them. So what I will do, I'm going to use for loop I in flower bracket 000000 dot dot 9999, and then what I need to do, I need to simply create a list. Okay, I'll use echo command for this. You can use anything. So copy and then paste and then space, and then here I need to paste that 4-digit pin number. Since I'm using I as a variable, I'm going to keep $I. Okay, and then done. So what this will do is this will create a list of it's better if I show this. Okay, I'm gonna write this, and if you see cat script.sh, you'll see these lines. Okay, so in order to execute this shell script, I'm gonna use bash. Since I haven't mentioned shebang, I have to use bash. Okay, script. So let's execute this bash script. Okay, and this is going to look something like this. Okay, it's better if I exit. Okay, I exited. What I will do now is I'm going to create the same thing, but instead of displaying on the terminal, I'm gonna create file named list. Okay, the list will contain all the list here. Okay, all these things. Okay, so it's done, and in order to check that, I'll just use head command and with the list. Okay, so these are the things that you'll be seeing. So what I'll do with this list now, I can just use netcat command as I used before, localhost 30,002, and input this list file which I have created. Okay, I'll just show you the list first. So this is the list file that was created here. Okay, so now I'm going to use this command, copy paste, and then let's see the outcome. If you are facing such error, as you can see, it has stopped in between. Looks like the slow connection or some other bug in this. Okay, so what I will do is I'm going to edit script. Okay, lot of numbers, 4-digit numbers have been executed, but most of them are wrong. So since we have seen that it starts from 0 and goes all the way to 9, it's stucking somewhere in the between, so we don't know. It's mainly because of some lag in the network or something like that. Okay, so looks like half of it is done. I'll just use some, okay, like 6,000 or something. Okay, so it might have gone till here. Okay, let's try to search from here to here. Okay, and I'll exit this and I need to remove the list file, and now I have to use the bash script and then list again to create a new list, and it is done. Now I'm going to use the same command and input the list. Okay, okay, all right. So looks like we got some secret password. We don't know that 4-digit pin number. We have to know that we need some extensive shell scripting, but we don't want to go that much depth. This is some basic shell scripting. Okay, so we got the password. I'm going to show in a couple of other ways as well. You can stay tuned. Okay, So just modifying the shell scripting. So what I'm going to do to this script is I'm gonna append each time the list with these numbers. Okay, so I'm gonna delete the previous list. Okay, and I'm gonna append. Double greater than symbol refers to append. Okay, so if this list is empty, it's gonna append with the first line. Okay, and then the second line, and then the third line, like that. Okay, and then what I'm going to do is I'm going to cat the list file which I have created over here using this for loop. Okay, that file will be created as we have seen before, and I'm going to directly send this to netcat command, localhost 30,002. Okay, you can also do this. Okay, and then if you see bash, and then before I do that, I'm going to remove list, and then now again I'm going to do bash script. Okay, now let's see what's going to happen. See, we got the password here again. Okay, and as you can see, we got the password again. Okay, so let's filter out a lot of this stuff. Okay, by filtering out, what I mean is, let's use grep for this. So for grep, we need to use some inverse kind of grep. So what I'm trying to do is I'm going to filter out these lines. Okay, you can take any one of those lines because the text in here is not repeated here. Okay, so what I will do is I'm going to use the same bash command and then grep it to -v, and then this one. Okay, so what it's going to do is it's going to filter out all these lines, and then whichever wrong text is not there, so that text will be printed. Okay, let's see. As you can see, this is much neater, right? This is much neat, right? So this is how you get the password, and we'll see each other in the next video. Alright, let's look at Bandit 25. This is also an interesting one. Let's look at this. Logging into Bandit 26 from Bandit 25 should be fairly easy. The shell for the user Bandit 26 is not bin bash. Okay, it's a different shell. It's not bash shell. Okay, but something else we don't know. Find out what it is, how it works, and how to break out of it. Alright, so we have some clues here, like VILS, something like that. So but anyway, let's get into it. SSH Bandit 25, and the password should be this one. Let's look at its file permissions. So it has 400 permissions. Just read permissions to the user. Okay, so it can be used to log into Bandit 26. Okay, so SSH Bandit 26 @localhost -i key, and you also need to mention port number 2220 because it is not default port. If you do not mention this, it's going to take port 22. Let me show that before I show anything else. So it's going to take port 22, which is not intended. Okay, so you need to mention 2220, which is the default, the port that they specified, right? So what do we get? Did we log into Bandit 26? No, it is still Bandit 25. Happening here, we are seeing this text, okay, other than this one, because when we logged in last time, So this is what happened. Okay, so enjoy you stay. So this is what happened when we logged into Bandit 25. When we're trying to log into Bandit 26, so we are getting some extra text. Okay, so this is being displayed on the terminal. We know various ways of displaying text on the terminal. You can use simply a cat command. So if you are using a cat command, it will simply display all the content regardless of its length or height or whatever. I mean, the content of the text is big or small. Okay, but here if you are using any other displaying something like more or less, then there is a chance of testing something else. Okay, so if you are using more to display only this part, so there will be something like this. Like if you try to minimize the terminal, it's gonna show how much percent of it is visible. Okay, and how much percent should be displayed more. Okay, so let's try to do that. As you can see, it is using more. Okay, it's not using less. So we came to know that it is using more. Okay, so one thing to know about more command is that it works based on VI. Okay, Vim editor, VI editor. As you can see here, this is Linux more command, and here you can see interactive commands for more are based on VI. Okay, so VI commands can be used in more. Okay, so to get into VI from more, okay, currently we are in more, we want to get into VI, we just have to press V. Okay, we have to just press V, and this we are in VI editor. That's the same text. Okay, nothing else, that's the same text. So if you see here, we still have the same text here. Okay, we are in VI editor, so we can use VI commands here. One thing you can do when you are in a VI editor is you can change the shell which you are using. Okay, so if you go to Bandit here, so it is saying it is not bin bash. Okay, it is something else. So let's try to use bin bash. Okay, so how to set that? You use set command here at the bottom. Okay, colon set. Okay, and shell and /bin/bash. So we want to use bash shell, so that's why we set the shell here. Okay, the shell is set now, so let's use the shell. So again you press :shell. Okay, and now we got bash shell. Okay, now let's find out what shell it is. Okay, so how to find out? Echo $shell. Okay, this is how you find out which shell you are using. If it is not bash, if it is something else, we need to know what it is. So echo $shell. So this is the content. Okay, so you copy this and let's see what's inside. This is just extra stuff. This is not related to the solution. Okay, this is some extra stuff which I'm showing you. Okay, so this show text is the shell. Okay, so what it is doing, it is using sh. Okay, and then it is exporting term equal to Linux and then executing more command here. Okay, so it is executing more command on this one. Okay, let's try to cat this as well. So you see, this is the Bandit 26 that was there when it is trying to log in. Okay, so now that's out of the way, let's try to get the password. /etc/bandit_pass bandit 26. Right, now let's see Bandit 26. So they're saying good job getting a shell, now hurry up and grab password for Bandit 27. So if you have saved the previous password, so you have to log in through that. So we are facing the same issue. So what we need to do is need to do the same thing like we did before. We set shell equals bin bash shell. So this is how we need to get the shell. So once we get the shell, so what they are saying, good job getting a shell. Now hurry up and get the password for Bandit 27. So the clue they have given is ls. So let's use ls. So we got a couple of these things. This we already know, we have seen in the previous video. This is just the text. If you see text, so that's that. And if you type ls-l, you will see these things. Okay, these are file permissions. You see an S here, which means the users who have executable permissions like this, or here there can be X. Okay, so those users can run this file with the permissions of Bandit 27, which is the user. Okay, which is the user here. Bandit 26 can run the file as Bandit 27. So that's what this S means. Okay, and let me run the Bandit 27. So it is saying example. Okay, and then ID. So ID is a command. Okay, we can just simply use the commands. Okay, ID, it will say Bandit 26 is the user and effective user is Bandit 27. Okay, let's see. And if you use Bandit 27, you can directly get the password using cat command, bandit underscore pass Bandit 27. So this is fairly easy. All you need to do is understand this set user ID permissions, right? Let's say Bandit 27. So there is a Git repository at this location. Okay, and the password for Bandit 27 Git is the same as the user of Bandit 27. Okay, so clone the repository and find the password for the next level. It is based on Git. If you don't know Git, it will be a little bit tricky to understand Git. It is nothing but a version control system. If you have ever seen GitHub or GitHub pages or GitHub repositories, that is just a repository. Okay, GitHub is repository. Okay, but Git is the underlying software that controls all the versions. Okay, so if you see 1.2 dot something, 1.3 dot something, or 20 dot something, you might have seen Ubuntu versions. Okay, Ubuntu versions 20.x, 16.x, all these versions. Basically every developer needs Git. Okay, every developer will have some versions, every developer will maintain some versions and go back to previous versions if needed. So all these things come under Git. Okay, but the storage place, which if they want to keep it public or private, so they'll try to store it in their local repository, or they can go to a cloud hosting repository such as GitHub. Okay, here if you see SSH is given, so it is in the local host, which means it is inside this host itself. Okay, this host itself, right? So you can use this URL. This can be considered as a URL, SSH, all these things. Before you do that, let's create 27. Okay, this is the one you need to go. Okay, and this is the password. Okay, and let's log into this first. GitHub, already explained. right? There's nothing. Okay, you cannot git clone or create any file over here. Whatever you want to do, you need to do it in a temporary directory. Okay, TMP. So you need to do in that directory. So instead of navigating to that or doing all this thing, you can use mktemp. Okay, and create a directory, right? So what I'm going to do is I'm going to cd into that, and then I'm going to copy paste this. So what this will do is it will go and search to this place, okay, for the repo. So for this you're going to need git clone command, git commands, some of the git commands you'll be using here. So git is the underlying software which controls all the versions. Okay, so what you're trying to do is you're cloning this repository into your home whichever directory you have mentioned. Okay, you cannot do it in the home directory, you do not have that much access. Okay, you have to do it in a temp directory. Okay, let's do that. So it's going to ask some password. If you use the normal git clone command like this, it should work, but you are using port 2220. So here you can see there is a port 22. It has taken a default port. Okay, to change the port you need to enter something extra here. Okay, port 2220. So if you do that, it should be able to ask for password, right? We got it. Copy, paste, done. Okay, we have downloaded 3 files. Okay, as it's saying 3 by 3. Okay, so that's how you do it. And if you do ls, there's repo, cd into repo, ls, there's a readme file, cat readme. The password for the next level is given here. Right. Alright, let's see the next one. Bandit 28. There is a git repository. Okay, the password is the same as Bandit 28. Okay, that's all you need to know. Clone the repository and find the password for the next level. So git. So you need to use git commands. Okay, let's see how it goes. SSH Bandit 28. Okay, now it's asking for password. This is the password. Let's create another one. 28, right? Paste the password. Done. So clear. As we have done previously, create another directory. Okay, temp directory. You cannot edit or download anything here, so you need to use a temp directory. So this is the shortcut. Copy cd into this. Okay, and then git clone this repo. You cannot directly download it since SSH uses a different port number. Okay, you cannot directly download it. So if you try to do that, it's gonna throw error. Okay, default port it is taking, but we need a different port. So to mention that, you need to go here. So Bandit 28 git localhost. Okay, so here you need to mention port 2220, and then rest of the command will go, rest of the repo. Okay, if you do that, it's gonna work. Okay, let's see this password. Okay, it has downloaded 9 objects. Okay, if you do ls, there is a repo, cd repo. Okay, there's a readme file. If you do cat readme, it's gonna say bandit 29. Okay, and then password is hidden. So this might be a different version. Okay, if you see git log, okay, git log will show all the logs. Okay, so git log -all. Oops, I missed a hyphen. Okay, -all. Okay, All right, if you see here, the head is pointing to the master branch and this commit. Okay, so it's not pointing to any other commit. If you see here, there is an additional commit here, and if you try to scroll down, there is one more commit. Okay, let's try to go through each commit and see if any changes is there. So head will point to the next this commit. Okay, let's see. Or else if you try to go to previous commits, okay, this is the latest commit, you want to go to previous commit, so this will be there, this will be the previous commit. So how to go there? Quit out of this. If you go to git log -p, will take you to the previous commit. Okay, previous, where do you want to go? You want to go to previous one level. Okay, so if you do that, it will say the head is still pointing to the same commit, but what it is showing is what are the changes between previous commit and this commit. Okay, that's what it is saying. So you scroll down a bit, you can see the password. You see, this has been deleted. Okay, minus means this has been deleted, this plus means this has been added. Okay, so if you see here, so this was the latest commit. Okay, this was one level before. Okay, so this will be our password for the next level, Bandit 29 password. Okay, if you still scroll down, you will see nothing, so Q to quit. And if you really want to change it to previous commit, what you need to do is you need to copy the commit which I have shown here. So this will be the previous commit. Okay, this is the latest commit, this is the previous commit. So if you want to change it, so all you need to do is git log git checkout. So what it will do is it will change the head to this. Okay, I will show you this commit. Right, head is now on this commit. Okay, this commit is the one which we have set. Okay, this one. So what it does is it detaches and point the head to a specified commit, okay, which we specified, and saves from creating a new branch. Okay, it does not create a new branch, it just navigates from one commit to another. Here we are just viewing the previous commits. Okay, now we have set the head to previous commit. So what will we see? Okay, what will we see? We will be seeing this part. Okay, this is what happened in the previous commit. So if you do ls, you will see the same readme file, but if you cat it, you will see this. All right, let's look at Bandit 29. So they're saying there's a git repository in this repo. Password for Bandit 29 is the same as Bandit 29. So clone this repository and find the password. Okay, so first of all, let's SSH into it. And this is the previous flag. Let me create. Right. All right, so if you see ls, there's nothing. So they're saying go to this directory, copy that, but before that mktemp fnd. All right, this is the same as usual. Copy cd into that, and then go back to this, copy, git clone this, git clone ssh bandit 29 localhost, and you need to mention the port. Do not forget the port. Okay, so this is the same as the port which ssh is running. Okay, if you do not mention, you'll get an error. Okay, right, and then what? Cat this, Okay, this is the password. Right, again, done. Okay, if you ls this, and you'll see a repo folder is there, so cd repo, and if you ls, there's a readme file, cat readme. They're saying there are no passwords in production. Okay, so usually in a software development scenario, one is production. Okay, so the one which is currently running, that one which clients can see, okay, the customers can see, that is production. Okay, another is the development, where actual development happens, and after they check everything, they'll push it to the production. Okay, so if it is not in the production, there it might be in the development. Okay, if you just do git log, you will see all of these things. Okay, so if you do git log -p, okay, you'll see everything. Okay, including all the changes also. Okay, including all the parent changes. And if you see here, you got the password. Okay, so this will be the password for Bandit 30. Just make a note of flag before we proceed further. Okay, so this is the password. Here you got it with one command. Okay, officially, if you want to check like where it is exactly, you have to check the branches. Okay, usually the production is in the master branch. If you see git branch, you will see which branch is currently working. Okay, so currently it is in master branch. But if you see git branch -r, so it will show all the other branches as well. Okay, here you see development branch. Okay, there is a master branch which is pointing to this head. Okay, and then there is something else, exploits dev. Okay, to get into one of these branches, okay, let's go to dev branch. You can say git checkout dev. Right now the branch is set up to track remote branch dev. Okay, from origin, switched to a new branch dev. Okay, so dev is also a branch. If we ls now, you will see there's a code and there's a readme file. And if you cat the readme file right now, you will see the password. Okay, so what we have done is we have moved from production to the development. Okay, back to the development, and then if you see the readme file, you will find the password. All right, let's see the next one, Bandit 30. Okay, so they're saying the same thing. Okay, there's a git repository here, and if you want to go to Bandit 30 git, you have to use the same password as Bandit 30, clone the repository and find the password, and no other clues. Okay, so let's log into Bandit 30 like this, and if you copy this, you'll go to Bandit 30. All right, and since it is the same thing, you need a temporary directory. Okay, cd into that, and then git clone this one. Since you're using SSH as a protocol, okay, you have to use the same port in which it is running. And yes, asking for password, the same thing as this. Right, ls, there's a repo there, cd repo, ls cat readme. So these are all the same things, and it is saying just an empty file. All right, So let's do the same thing. Git log -- all, and see, we can see only one commit, and the author is bend over, right? And there's only one commit. What to do in this branch? Let's see the branches. Git branch -r. We see only single branch. We don't see any other branches like dev branch or any other branch. And now we have to see something else. So usually when you commit, you make all the changes into a new version, right? Like a 1.2, 1.3.x. okay. So while doing that, you refer it to a tag, okay. So there will be git tags, okay. We also have to check the tags, and here we see a tag, okay. There's a secret tag here, and if you go to git show secret like this, you will get the password, okay. There is another way to do it. So this is the shortcut way. Let me show you another way. The another way to solve this is to just ls-l, and here we see git repository, okay. This is a directory, so cd into that, and if you ls, we see a lot of this content, okay. So usually when you're doing all the tags and all, you will usually refer to this packet.refs, okay. You have to refer this. It will be packed with all the tags and all other things, okay. So if you cat this file, you will see what it is, okay. So this commit refers to this master branch, and this is referring to this secret tag. So once you found out that there are tags, okay, you just copy this and then git show secret. Okay, this is another way to solve this. Okay, alright, let's see the next one. So it's the same thing. So there is a repository, and bandit31 password is the same as bandit31. Clone the repository and find the password, okay. So SSH into the same thing, 31, and password is this. And if you ls, there's nothing. mktemp, again you need to create a directory, okay, to clone the repository, okay. cd into that and git clone, and this repository, okay. And here you need to change the port because we are using SSH protocol, so we are mentioning the same port as this one, and s, and same password. Oh shit. Done. cd into repo. Let's ls cat readme. So this time your task is to push a file to the remote repository, okay. By remote repository, they are saying that this is the remote repository, okay. So don't worry about that. So just push, okay, git push, that's enough. And the details are, the file name should be this, and the content should be this, okay, and the master branch should be there, okay. So first of all, let's check the branch which we are in. So we are still in master branch, so no need to worry about this branch part, okay. This is done. So next thing you need to do is you need to create a file, okay, and then push it with this content. Since it is asking for this content, so it's probably a text file, okay. You can do it in a couple of ways. So you can use echo command, simply echo command, may I come in, okay, and then question mark, quotes, and redirect it to a key.txt. Okay, this you can do, right? By doing this, you can create the key file. Okay, here a new file is created. The next step is you need to add, okay, you need to add this file to the repository. Okay, that will be called as staging. So what you need to do is git add -file key. This file is what you're adding to the repository. Usually what other people will do is they will simply do git add and then star. So add every file to the repository. So that's what they usually do. But if you want to specify a file, okay, you can do it like this. Okay, and now these things are ready to be shipped. Okay, so this file with the content is ready. Okay, and this is added for delivery. Okay, so this will be ready to send it to the repo. So this is inside the repo, but it's not a part of the repo. Okay, so now you have to do is you need to commit the changes. Okay, now I'm ready. Now I'm committing the changes. So commit -m. So -m stands for message. Okay, you need to give a message like anything, it doesn't matter. Okay, so once you send some message, okay, lol, something like that, anything, it doesn't matter, the message doesn't matter, it's just some notation. Okay, and you're committing the changes, and once you do, you have committed the changes. Okay, let me give you a brief of what actually happening here. Okay, so let's take this as my PC. Okay, so and this is a remote repository. Okay, remote. Okay, and this is local. So you can run git with all the versions in the local repository itself, but what they want us to do is you need to push it to the remote repository. Okay, here if you see, your task is to push a file to the remote repository. So what here we have done is, so this is the first step in which we have added a file, okay, to this repository. Okay, from remote, from SSH and some repo to our repo, and then we have added this file. Okay, added this file, and now we have to say, okay, I'm ready. Okay, I'm committing the changes, and this is still in local branch. Okay, so this has been upgraded already. So after this commit, it has been upgraded to latest version. Okay, and new changes has been done. The final thing we need to do is we need to push it to the remote repository. So that's the final step. Okay, you have added a file, you have committed the changes, it has been upgraded, so this has to be upgraded. Okay, so the final command that we need to do is git push. Okay, here if you see, all we have done is this, and git push, and yes, and yes again, like we need to set the password. Git push failed. Okay, it is failed, but what happened is attempted to validate the files. Okay, and here's some extra message, well done, here's the password for next level. Okay, we got the password, but what they have done is they have rejected. Okay, it's fine, we got the password. So it has to be this way, because if we keep on updating this repository, so everyone else will be using the same repository, so it will be clumsy. Okay, so they have made it such a way that we get the password and then reject the reject the push. Okay, remote repository is not updated, but when we are trying to update, it just validate the check and then it gave us the password, right? All right, let's see the next one. Bandit 32. After all the git stuff, it's time for another escape. Good luck. So they have given man and sh. Let's see what it is. Let's get into it. Pasting the password. So we know that till here the usual, and here we got something extra here. So welcome to the uppercase shell, and then we have got some prompt here. Let's try to execute something. Okay, let's say hello. So if you see here, when we try to execute something, okay, it's converting it into uppercase letters, and the sh shell has been used, okay, not bash shell. Okay, these two things you need to understand, that whatever we are giving, it is taking it as an input and it is converting it into uppercase, and sh has been used as a shell interpreter to execute this command. Okay, but if you give anything, okay, if you give cat and something like that, it's saying cat not found. So this command has been converted into uppercase letter. So let me tell you one small concept. This is related to variables, okay, variables in the shell. Okay, whenever we try to execute a script, let's say there's a script, okay, .sh, we have executed these scripts like this before, and let's say we are executing something cat and something else. Okay, so what is happening? So this script is running with the arguments like this. Okay, so inside the script, these arguments are given numbers. Okay, numbers or variables, you can say. These are called special variables. Usually the second one, this one is numbered as $1, okay, and this one is numbered as $2, okay, and there is a special variable $0, which is the name of the script itself. Okay, so if you see here, sh is being used. So if you type $0, the name of the file is being skipped because these are not part of alphabets, so there is no uppercase, so this part will be skipped, and whenever it's trying to execute, okay, this shell will be executed. The script may be something like this, okay, sh and some uppercase script, okay, uppercase script. So this will be something like this. So okay, so uppercase script has been run using this shell interpreter. So if you try to use $0, okay, this will be the name of the script. Okay, it will be like sh, okay. So you can run a shell using another shell. Okay, it will be something like this, and shell we will get something like a dollar symbol. Okay, but we are still using uppercase shell. Okay, so here something like this, we got a shell. You can actually go and use this, and let me get out of this. Okay, we have got a functioning shell, okay, that is sh. Okay, we got sh here. Okay, but we can also get some other shell called bash. Here itself you can execute the command like cat command etc bandit pass and get the password. Okay, if you try to exit from the bash shell, okay, I go back to this shell. Okay, and if I try to check which shell has been used, echo $shell, I'm using uppercase shell. Okay, this is the shell that I'm using. Let me try to get the password. Okay, cat/etc/bandit pass. There's one small thing that's missing in shell, actually the sh shell. Okay, so if you try to tab, it doesn't auto complete. Okay, but if you use a bash shell, okay, things become easier. Okay, so cat/etc
bandit. Okay, but now the tabulator is working, and bandit 32 or 33. I got the password. Right. I'll finish 33 here itself. Let me try to SSH into it. Okay. Let me get the password. And if you ls, you see readme.txt cat readme. Right. So what does it say? Congratulations on solving the last level of this game. At this moment, there are no more levels to play on this game. However, we are constantly working on new levels. We'll most likely expand this game with more levels soon. Keep an eye out for the announcement on our usual communication channels. In the meantime, you could play some of our other war games. Okay, if you have an idea for an awesome new level, please let us know. Alright, we have completed Bandit. Now let me see what I can do next. I'll be doing Leviathan. It's a similar kind of a game, so it's similar to Linux. A little bit reverse engineering and other things are there. Other than that, we'll continue with Leviathan. Okay, I'll see you guys in Leviathan. Bye bye.